By the way, Bill, tomorrow, do you want me to plan to Kalispell City or?
No, Glacier.
I never heard anything tonight. Yeah, it's just like I have.
We get so many calls.
We would get
Our own live.
That's true.
Does you have a pen?
Nope. If I did. No, I didn't.
I would give you
No, I
a
have a
friend.
pen.
Thanks.
Oh, thanks.
Wow,
Legit?
I should have done that. It's a great idea.
Why did you do that?
Your Cali Cat.
Okay,
I was thinking, I don't think I have.
that was the sickest thing I've ever done in my whole life. I just want you to know that.
You peaked.
And I was a gymnast.
Weird to have to bring that up, but okay.
Well, because like, that was catching a pen was where that was it.
I didn't hear that.
All right, it's 5 o'clock.
Good job.
Okay. So corrections and clarifications. Not a correction so much as just a clarification. Nicole actually figured it out last week for sure. I went back and double checked. So the only altitude on your step down fix that is not plus or minus 100 is the MDA. So your minimum descent altitude, and what is it?
For real?
It's plus 100 minus 0.
Exactly. So, and on your check ride, you have to go plus 100, minus 100 on all the other fixes, and you have to go plus 0 or minus 0 plus 100 on the MDA. You can't sit above it. All right. In the real world, it is perfectly acceptable to stay above. So, is your dad coming back?
Yes, he will be, but the front left brake is seized.
Oh,
Yeah.
Wait, you drove it here?
I had no idea. It was driving just fine when I thought it was driving just fine when we left the house. It wasn't until I got up to like 60 miles an hour on the highway, because the back way is down here, that all of a sudden it started pulling really hard to the left. So
Yeah. Probably hit brakes too.
this is why my mom doesn't drive my truck.
okay. That's now recorded for all posterity.
Whoops.
Right, but so yeah, so the question came up, plus or minus 50, plus or minus 100. I went through every single one of them. Now it's all if there's a final altitude. So like you can't blow through the DA. You go to the DA plus 100 minus 0, and then you go mixed. You cool beans? All right. So. Between class this week and next week, I would suggest you open up the ACS and go through it to get a feel for what's in there. While we were on a flight the other day, Nicole pointed out to me that so I haven't taken a check ride in like a decade or more. Not an instrument check ride anyway, in a long time. I didn't realize you could use the autopilot. You have to demonstrate the autopilot on one of the approaches. Did I get that right?
Yes.
So when we're out flying, Dylan and I went flying yesterday. Parts of it we will do with the autopilot on. Parts of it we'll make the hand fly, and we kind of keep switching back and forth. The good news is you all had Nicole at some point in your careers, and you have learned how to actually fly an airplane, hold altitude, hold heading. What's that? Yeah, you actually do it. A lot of people get the private pilots, and they wander all over the place. Is that you? I haven't flown with you yet. So we'll learn. But, so because of that, this is going pretty fast. You guys are doing well. I think we got kind of a good blend where we spend a little bit of time in the sim. Sometimes we practice something, and then we go out the next time and we actually fly it. So I am very deliberately doing your live flights so that they are valid cross countries, so that you're building PIC cross country time. Because of this, our flights are long. So I told you, if you're getting ready to plan something, you need at least a 3, maybe a 4 hour block to go fly it. So for planning purposes, work through that. But all that time counts towards your 40 hours that you need for PIC time. So we're checking all those boxes you have to check to keep it as efficient as we can. All right. Okay, so now really a review question. I did have a good conversation with Dave, and he thinks the one place where the private students come out a little weak nowadays is with VORs. Now that was after I started hammering the crap out of you guys in the sim on VORs. I am firmly convinced that if you can fly VOR, you can fly anything. Virtual, does that make sense to you?
Totally.
Yeah, so you'll notice I'm going to do a lot of just hard, weird VOR approaches and VOR exercises in the sim, and we're going to do VOR, and then we're going to go out and we're going to fly VOR stuff, and then when we start doing GPS stuff, you guys have already figured this out. The departures are not that hard, right? The plane will only climb so fast. You did have to meet gates, and you had me sitting there going, yeah, all right, you need to climb faster, or we're not going to make the gate. But so what I do with you guys now, yeah, all of you except Mir, because you're just not there yet. But all the rest of you guys, it's plan a route. We're going to go somewhere. You're going to fly a departure if there's one available. And then, like, you had your first flight like that. I file it, and I open the flight plan. You guys listen to me do it, so that you can get some experience with what that sounds like on the radio. And then probably the next one, I will file the flight plan. I will tell you what I filed, and then you will do radio calls. And if you make a mistake on a radio call, you may see me go like this. That means stop saying what you're saying, because the only thing that will happen is you'll annoy a controller, and then they get to be challenging to work with. So I will talk about like some of when you make your radio calls. Number one, when you first check on with a new person, you will always just altitude and call sign. Don't give them a novel. They know you're coming onto the frequency. They don't realize that you have a life's goal that you want to ask them to help you fulfill, and they're not ready to copy that all down. All right, so they give you the courtesy of telling you, hey, I've got an amendment to your clearance, tell me when you're ready to copy. So what we do instead, what do we do, Callie? Instead of just flooding them.
Instead of what?
You're checking onto the frequency and you want to do something specific.
Oh, so we'll say Seattle Center 19698 workload permitting with request. So whenever they have a moment, it's not incredibly crucial that we talk to them now.
And they also know if we're going to ask them for something and it's not good for them, then we will work around and do something else. Okay? So perfect. But don't just fire hose them with what your request is, because sometimes it's the wrong person. And early on, I will tell you when to ask for things so that you're not asking the wrong person.
And we've been told before, we tried to ask Spokane Approach for something, and they said, talk to Seattle Center when we switch it back over.
So yeah. So if I get it wrong, that's on me. And usually they're pretty nice about it, especially if you start off with workload permitting request. You ask the request and they're like, I can't do that. The next guy has to do it. What is happening now is I'm flying the area enough that I'm starting to get a feel for who the right person is to ask for a request. So Callie flew some crazy stuff yesterday. Virtual did some crazy stuff today as far as coordinating with Center mostly. And both of those were we came off of Lewiston and flew to Pullman. And Callie's, you want to tell them the story in Pullman?
Well, basically, on the way into Lewiston, we were flying the DMER, and we heard people talking to Center in Pullman. There was 2 Horizon flights or something like that, and there was a mix-up between who has a clearance and somebody repeated somebody else's clearance and it got weird. And so there was two planes trying to take off and it was super weird. So we flew the DMER, landed it at Lewiston, taxied back, took off from Lewiston, and as soon as they swapped us to center again, we still heard them talking. So we thought, we don't really want to fly there. So we called up Seattle Center, and because all of that chaos was going on, we just asked to divert to 650. So we changed our flight plan like on the fly.
So the takeaway I want everybody to have from that is, if you're paying attention and you hear something that you don't want to get mixed up in, you can change your plan. Just because you have a filed flight plan doesn't mean you're married to that flight plan. ATC will change your plan for you sometimes because it's better for them. But sometimes, and I think the ATC actually genuinely appreciated that we said, hey, we don't want to get mixed up in those two airliners sitting on the ground that you can't figure out who's flying. It was funny. And then Virtual, we did something complicated, it was planned. But you want to talk them through what we did today after part of Lewiston?
Yeah, so I was trying to figure out how to get from Lewiston to Pullman, and like the departure procedure doesn't actually connect to the instrument approach procedure from one to the other. So you got to kind of figure out, like, am I going to go all the way to the VOR and then come back out? But once we got off, then we called them and asked for the straight in. They're like, oh yeah, sure. And so instead of like our flight plan said we're actually going to have to go over here and come back, but once you're talking to them, they're just like, okay, go straight. And they actually, there was one point where he had us add something to make sure that that was as they were coming down. They actually added in a fix on our way in to set us up for a better angle onto the DMER, which is also interesting.
And then kind of the final one was we flew the approach into Pullman and let them know ahead of time we were going to execute the full missed approach. And they treated it just like a regular missed approach. She cleared us to go in and land. We went down. They switched us over to the advisory frequency. We talked to the airplanes there. There's actually an airplane in the pattern flying the opposite direction of the approach we were on. And we were able to tell them, hey, we're not actually going to land, so we can work with you. And then when Virtual came around, he made the turn for the mist, was headed back to Pullman. And she's like, well, do you want to do a turn in the hold, or do you want to just go direct up to 65 Sierra? So we went through the entire process of a missed approach and then diverting to another airport. So ATC will work with us. And Dylan got to experience listening to me talk to ATC. But, did they work with us?
Very much so.
So, yeah. A lot of people have fear of talking to ATC. Yeah, the biggest thing is pay attention and listen for when they come in. All right. So flying to VOR and DME. All right. Now I'm going to see if I can get the right. There we go.
Every time they repeat a call to you that you miss, their voice goes up a half an octave. By the third call, they're pretty pissed.
Yeah. So now, if you do if you miss a call, so Virtual had one today. We thought we missed a call, and he just asked, and hey, was that for? I forgot your tail number.
Yeah, 72 X-ray. He's like, nope, not you.
Negative.
Yep.
So they will tell
There was
us.
one other where we did miss a call the first time. Because it's radio's just sketch some altitudes, and they called the second time. I know we caught it the second time, so we were still okay.
All right. Oh, that did not do what I was expecting it to do. Cannot hit the wrong button. There we go. All right. I don't know how loud this is going to be.
Hi, it's Dan with Flight Insights.
No, this
We're looking
sucks.
at the DMER here. You might see these on approach or departure procedures where procedure turns aren't used like mountainous areas or near obstructions.
All right.
It's the FAA's way of telling you that
I had this working one time.
It's the engine, it's the sound of the jet engine. Sound for 4 years.
flying sounds good.
I'm here to simplify this weather theory so you know what to look for as a pilot. In this lesson, we'll expand on the weather information you learned as a private pilot.
And dive a little deeper into the subjects covered in the instrument knowledge test. The weather fundamental subjects include the atmosphere, air masses, fronts, and jet streams.
Different video. Let's see.
They want you to stay a constant distance or DME away.
Alright.
Hi, it's Dan with Flight Insight, and we're looking at the DME arc here. You might see these on approach or departure procedures where procedure turns aren't used like in mountainous areas or near obstructions. If you get a DME arc, it's just the FAA's way of telling you they want you to stay a constant distance or DME away from a station until you reach the next step of a procedure. Using your heading indicator, a VOR receiver, and of course a DME, you'll be able to tell where you are on the arc and when to start turns to keep you on it. Here we've whiteboarded the DME arc out. It involves two 90-degree turns, one to enter and one to leave the arc, then a series of small 10-degree turns to stay on the arc at a constant distance from the station. Let's look at the VOR approach to runway 31 in Atlantic City. You see the two arcs to the north and south of the approach course and the big note saying DME is required. Let's focus in on the southern arc, which takes us just along the coastline clear below those casino high-rises on the boardwalk. As always, we'll rebuild this approach on our whiteboard, starting with the VOR station itself, located right on the field, and then move the procedure over to the left for now. We can get set up for the arc by flying outbound from the station on the 174 radial. The DME arc starts 11 nautical miles from the station at a point identified as Avalo. It's noted by the triangle and the number 11 inside that elongated D for DME. From Avalo, we'll arc to the north and east, staying 11 miles away from the Atlantic City VOR the whole time until we reach the inbound course for the approach at 302 heading. Just note that this isn't the 302 radial, but the reciprocal of that. It's the 122 radial. In any case, though, we're flying a 302 heading that'll align us with runway 31. Let's get a closer look at the arc. From the time we depart Avalo, we'll be making heading changes to the left in order to stay 11 miles from the station. Our DME receiver, or your distance measured on your GPS, will help us confirm that we're staying on the arc. It's all too easy to veer away from the arc by, for example, not turning enough so the aircraft drifts further away from the station as the DME shows, so we need some way to tell us when to turn. This is where the VOR receiver comes in. We can identify a series of radials from the station that will tell us exactly where we are on the arc. So just like Avalo is on the 174 radial, we can mark other positions on, say, every 10th radial from there. So like the 164, 154, 144 radial, and so on. Then what we can do is, instead of thinking of the arc as one continuous left turn, we can split it up into segments, each with a 10-degree turn at a time, starting at the radials we identified. So we've turned the arc from a perfect circle into a portion of a sort of 36-sided polygon. Now we'll get set up by intercepting the 174 radial outbound. We've got 174 selected on the VOR and are flying an intercept heading of about 145 degrees. When the needle centers, we'll turn to the outbound course of 174, and we know we're approaching Avalo when the DME gets closer to 11. From Avalo, we'll make a 90-degree turn to start the arc. The arc starts and ends with 90-degree turns, but you don't have to do the math. Pilots should never do hard math. Even smart pilots lose about 30 IQ points in the cockpit. Just too much going on. To figure out what a 90-degree left turn is, just look at the left red arrow on the heading indicator, which would be 84 degrees, and fly that. Now we're ready to start flying the arc, but we want to know when it's time for the next left turn. We'll want to turn again when we cross the next radial 10 degrees away, so we'll twist 10 degrees in the VOR, sending the needle to the left. Which way do we twist? Well, we're arcing with turns to the left, so the numbers decrease, just like in any left turn. If we were arcing right, we'd increase the radials. Now we'll fly our heading until we cross that next radial, as indicated by the needle coming to the center. When that happens, we'll turn 10 degrees left and twist 10 degrees left, continuing to fly on that new heading. Once the needle centers again, It's another round of turn 10, twist 10, and flying the next segment. If all goes well, our DME will show that we're staying 11 miles from the station.
Wouldn't that be
The
easier?
checker has to maintain the arc within 1 mile, and turn 10, twist 10 can help you make the turns at the right times to stay close. Keep an eye on what radial we're on. Remember, our inbound course is 302, so we'll want to enter the approach segment when 302 is on the bottom of the VOR receiver. Again, it's not the 302 radial we're flying, it's its reciprocal. Now it's time for the second 90-degree turn to exit the arc and enter the final approach course. We'll turn inbound and then twist the VOR so the inbound course is now on top. Notice the flag flips from to 2, and from there we fly inbound like we would on any VOR approach, noticing the DME distance getting smaller as we approach. It's easy to overcomplicate a DME arc. Just remember that we want to stay as...
Alright.
30 IQ points, huh?
Yeah, I don't know if that's a scientifically derived number, but
It assumes you have more than 30 to begin with.
I was about to
Exactly.
say, that explains why Noah wasn't talking when he flew with Nicole and I.
he's not even here to defend himself, man. Alright, so somebody remind me, and I will put a link to that video. If you can fly a DME arc, you can do almost any navigation action that you need to do. And they're not that hard. You turn 10, you twist 10. You know, I drew this up here. Now I know my arc got flat at the top. It's because I'm short. I ran out of altitude. But if you're on the 270 radial, if you fly in, you catch the radial, and you fly out, you're just going to turn 90 degrees to north. All right? And you'll fly until you go 10 degrees, and then you'll turn 10 degrees to the right, so to 010. And if you look, what that does is you're constantly flying these little flat bends, and they're perpendicular to the radial as you come across it. Now, the only thing that throws that off is wind correction. And like Virtual and I flew a really long arc today. One of the comments I had was the wind is going to change as you're going around the arc because you're making a curve. So be prepared for that. But the big thing is you keep the distance the same, and then you turn 10, twist 10, and if you're flying away, you turn in a little bit more. So this morning we were doing what did we start doing? Like
turn 15-ish sometimes.
15-ish, bring it back in, get it cleaned up, and you have to stay within a mile of the arc. So most people kind of serpentine along it a little bit. For those of you, serpentine just means to move like a snake. So just zigzag around it. All right. Now let's get on to...
For those of you who were born up here, you might not know this snake is.
You don't have snakes up here?
Yeah, little garden.
Yeah,
I grew up with rattlesnakes, so. Okay. All right, so today's topic is actually weather theory. A quick story. I've made an entire outline of this from Rod Machado's book. And then I went back and I started from scratch. So this is actually version 2 of the slide deck. So it does not follow the order of Rod's book. Rod's book has really good descriptions. It goes a little too far into some of the topics for what you're going to need to know for the test. So I went back and I used a couple of other sources to not dial it back, because we're actually going to talk more in depth about a couple of topics, but to make it more focused, specific to stuff that you're either going to care about for your written test, for your oral test, and then finally for actually flying. Okay. Partly because I figured out a couple of things I was never really taught well, because I learned to fly in Georgia. I did all my instrument training in Georgia. We don't really worry about icing a lot. So, all right. So critical hazards include, I should have asked what critical hazards, so.
I mean, you can hop off the slide real quick.
There you go, okay. So as a private pilot, what do we care about when we look at the weather?
Segments, airments, clouds.
Okay,
Visibility.
visibility, clouds. I'm liking this. All right, when you're planning to go on a cross country for fun, for a VFR cross country, you want to run down to Coeur d'Alene or over to Kalispell or whatever. What do you really check?
Whether it's clear or not. That's private pilot.
Whether it's VFR,
Winds aloft.
ceiling.
We do look at winds aloft. That's a good one. Why do we care about winds aloft as a VFR pilot?
Because you want to know how much gas you're going to use. You want to make sure you have a tailwind on that day.
Yeah.
And also mechanical turbulence. Since we're in a mountainous area, if winds aloft are 25, I'm not liking it.
Okay. So we got winds aloft. You said clouds. You said visibility. So
On the ground at the
What's that?
airport.
winds on the ground at the airport. All right. But what we're looking for is, I think the first thing everybody does, correct me if you're wrong, is you open up ForeFlight on the page with the little colored dots, and you look for a lot of green. You know? And if you've been a little experienced, you might even look at the blue spots if they're on the edges, if it's close to where you're going, because you think you can slide in, right? But that's everything. We look at what the current rate weather says. Is it VFR? And then we look at the TAFs to see if we think it's going to stay VFR or if it's going to get better, you know? So what we care about, though, is you cannot go in the clouds. It's not an option. So am I going to be able to get to where I want to go without going in the clouds? And are the winds going to be conducive to my fuel requirements and my skill level? Does that sound about fair?
Yeah, that sounds about fair.
And that's,
Storms moving in.
And the ability of your aircraft to handle.
yeah, but bottom line is, when you look on there and you see that the ceilings are at 900 feet, your discussion's over. You're not going, right? If there's obscurations in your way, if you can't see, if the winds are a little howling, we don't go. Storms in the air. I know lots of private pilots that will not fly if it's raining. Like, that the idea of flying in the rain baffles them. I'm like, it's raining. The plane will fly just fine. In fact, it gets washed. You know. So
Please fly in the rain.
okay, but so your critical weather decisions as a VFR pilot, though, are: do I have visibility? Do the ceilings work for me? And are the winds within my comfort level? And I would say that if there are storms there, all of those are out the window. You know, storms have bad winds and the ceilings get bad.
Stuff changes fast.
Yeah. All right. So, from an IFR perspective, though, you know, what are we getting our IFR license for? What's the whole point?
To fly in clouds.
Flying clouds. To get places, even if there might be clouds in the way.
Exactly.
Right? I want to go somewhere.
So to be less encumbered, to have the option to go. All right. So what kind of threats do we face when we're looking at weather? What's that?
Icing.
Icing is absolutely so. It is extremely rare below 18,000 feet to get clear air icing. You can get it. You will get it here. Right. You guys see clear air icing here?
Not that I've ever seen it.
Okay, but it's just extremely rare at this altitude because it's too warm and you don't have enough moisture to really make it happen. All right, if it's clear air. So yeah, we talked about icing, but if you're VFR, you don't run into icing because you have to fly through visible moisture that is near the freezing temperature. And you'll notice I said near, because it doesn't have to be at the freezing temperature. It can be a little bit above it, but due to your motion through the air, you could actually be cold enough to have it freeze. All right, what else what else is going to get us as IFR pilots?
Embedded thunderstorms.
Absolutely. If you're in clouds, you can't see the thunderstorms. How do we avoid thunderstorms as a VFR pilot? We look outside the plane. All right. So thunderstorms, severe weather, embedded thunderstorms. All right, what else do we have?
You still have wind shear and turbulence.
Absolutely. In fact, you're much more likely to experience it because we fly in harder weather. One of the things we do is we use the levels, our flight levels, to try to get out of the worst of it and still get where we want to go.
We still have visibility and ceiling minimums as well.
There's low visibility. I'll tell you one that will bust you. Fog. Fog becomes much more important to you as an IFR pilot because if you plan a route and everything's good, but your temperature dew point spread is tight and you're landing at dusk or dawn, someplace that was perfectly clear and forecast to be clear can suddenly be not. I mean, like minutes. And then we're going to throw in mountain waves. Just because we fly in harder weather, you're more likely to deal with some mountain waves. And then frontal systems. All right. So, as an IFR pilot, if you see a line of thunderstorms, you won't even try it. You'll stay on the ground because all the weather around that is just not good. Ceilings are low, everything's bad. As an IFR pilot, you may decide you want to try to navigate through that. That depends on the capabilities of your aircraft and what equipment you have. But so if you look, we have a lot more nuanced view of weather. All right, we care about more things. I don't know how many times I have stood here and been like, well, let's just file and go. And Nicole looks at me and goes, yeah, there's going to be freezing. There's going to be icing. I'm like, yeah. It's because icing is the one that I'm just horrible about. It just doesn't leap to mind for me. All right. So what is the primary cause of all weather?
Heat exchange. Nah, that's what it is.
No, go.
You're right there.
You're right there.
This is the one I missed.
Okay, the FAA has an answer they really like, but
Adjective.
no. So heat exchange.
Differential heating of the Earth's surface.
Yep, the unequal, and they like to go with the unequal solar exchange of heat with the Earth's surface. Water and Earth heat and cool at different rates. All right. What else affects and causes uneven heating of the Earth's surface?
Snow or a plowed field or green grass or asphalt.
So color and surface texture. There's also a huge one that when you hear it, you're just going to be like, I knew that. Well, mountains, I will give you, south face is going to heat up more than the north face.
Forests.
I'm going to lump that in with texture and temperature, texture, color.
Lakes.
Well, lakes is water versus land.
Cities.
Angle of impact of the sun. That's why we have seasons, because the angle changes, right? So during the summer in the northern hemisphere, we get a more direct sunlight. That is actually the major reason why it's hotter in the summer. We're not closer to the sun,
Actually, further from the sun.
But the
sun is coming straight down on us instead of hitting us at an angle. And so the same amount of sunbeam is covering a smaller area on the Earth, more focused during the summer. During the winter, we get a more oblique angle, and it's just colder. And for us, that also means daylight is longer and shorter, those sort of things. But the primary thing is uneven solar energy, land versus water, angle of incidence. All right. So the air around the Earth ends up in like layers, and those layers have some common traits that will change. Now, I don't want to talk about 3 layers, and when we get done, we'll understand why I don't care about the rest of the layers. But the 3 layers, what's the layer that's closest to the Earth? Anybody know?
Troposphere?
Oh!
Nice.
Dude, did you study?
A little bit.
There you go. Okay, what's interesting about the troposphere? What makes the troposphere the troposphere?
As far as I got, it's the troposphere.
Okay. Anybody have any idea what makes the troposphere?
It's warm, like tropic. No.
Most
No.
weather happens in it, and it has your standard lapse rate of everything.
So
It's
it's
the thermosphere.
so the troposphere. Say it again.
Oh, most weather happens in the troposphere.
There's almost no weather in any of the other layers. All right. So, and then above the troposphere, you have a very thin layer. You know what that's called?
Tropopause.
Oh, I got the tropopause. There you go. Do you know what it's marked by? What happens at the tropopause?
Temperature inversion.
Sort of. Yeah, a dramatic change in the temperature lapse rate. Sometimes it's an inversion, sometimes it's not. But it's, and then above the tropopause,
Stratosphere.
there you go, stratosphere. And what happens in the stratosphere?
Nothing.
It's warmer as you go up.
That's the inversion point. It actually gets warmer as you go up.
At what point does it start getting colder again?
So it gets colder at the stratopause, and then the mesosphere gets super, super cold. Then the mesopause, and then the thermosphere gets really, really hot, like 2,000 degrees or something.
And then it gets colder after that.
Well, that's like up in the
Then
vacuum of
space.
space. So it's
Space
So you like it near 0 Kelvin?
Then it's no longer moving with Earth.
Yeah.
It's leaving it behind.
So for your study, you care about the troposphere, the tropopause, and the stratosphere. And you notice I went from bottom to top. I left them on the slide in this order because that's the order we talk about them. Did I get that right? Yeah. That's the order they are on the Earth. Sorry, we're going to talk about them from bottom to top. But they're confusing myself.
the bottom one's closer to Earth.
That's yes. Thank you. So, but these are the ones that you, when you're studying for your tests, this is what you're going to care about. Your questions are most likely going to talk about the troposphere or the tropopause or the stratosphere. Everything above that is too high for us to fly. So we don't care. All right? And the troposphere is the most likely for you to get questions about. Why?
That's where most of it happens.
That's what we normally take off.
It's where weather happens. There's no weather up above. It's just cold, icy crystals.
Yeah, a little bit of weather.
And there are jet streams, you know, that run up in. Okay, so troposphere. Almost all weather happens in the troposphere. It's at approximately 37,000 feet in the middle latitudes, but it varies, and it can vary dramatically, down to like 18,000. The top can come down to about 18,000 feet up by the poles. But it changes with the seasons. It changes with
Different pressure days.
it just changes. It changes with the uneven heat exchange on the ground. All right. The standard lapse rate. This is definitely questions you're going to hear over and over and over again. Is 2 degrees centigrade per 1,000 feet. This is a memory item. This is something that should be on that little sheet you prep to walk into your test that you just copied down 1,000 times. Standard lapse rate is 2 degrees per 1,000 feet. What's the standard pressure change?
1 inch of mercury per 1,000.
1 inch of mercury per 1,000 feet. That is not hard to remember. All right? But those need to be on your test or on your study guide. All right. So then the tropopause, the big thing is it's the big transition between the troposphere and the stratosphere. All right? And the bottom of it starts at about 37,000 feet in the middle latitudes and can come all the way down to as low. It's typically like 24,000 feet at the poles, but it can come down. Am I getting that right?
It can come down pretty low.
And
It changes.
It changes. All right? And there's an abrupt change in temperature and a dramatic reduction in weather, just the amount of weather. All right. If you're flying an airliner, you could be flying above the tropopause in the stratosphere, just 37,000 feet. We routinely fly 40, 42. You know, SR-71. Anybody know what flight level it flew at?
That's classified.
Yeah, the top of There's a great story about them requesting flight level 600 and the flight.
Yeah, if you can get there.
If you can get there, you go,
Descending down. Yeah.
yep,
Descending down.
descending now. But so abrupt changes in temperature lapse rate. Let's move to the stratosphere. Okay, stratosphere, big thing. It's very dry. There's not a lot of moisture in the stratosphere, which is part of the reason why there's not a lot of weather in the stratosphere. Also, it's a very long way from the unevenly heated Earth's surface, and so it becomes much more homogeneous. So just, it's all kind of, it's much more likely to be about the same temperature, but the change in variance will be all the way around on the other side of the Earth, not within 10 miles. All right, very little weather, relatively small temperature lapse rate. Oh man, okay, yeah. Cloud families, this is just a review from private, but there are questions on the written test. So you should know that there are 4 cloud families. What are the 4 cloud families?
High, middle, low, extensive.
Exactly. All right, so.
If you're gonna read it off the slide, you may as well read it loud.
Exactly, with some confidence. I didn't exactly give you a trick question. All right, so let's talk about high clouds. What defines a high cloud? What makes it high?
Altitude?
What altitudes?
Stratosphere?
No. Interestingly, they don't. It's so high clouds will bridge between the top of the troposphere and into the stratosphere.
So you just hang out in the tropopause.
But what's that?
So you pretty much hang out in the tropopause.
Get shoved around by the tropopause probably. But so bases, 16,500 feet is the official answer to 45,000 feet. That's where the bottom of high clouds are. Almost entirely made of ice crystals. Very unlikely to result in icing. Because ice crystals don't make icing.
That's what the cirrus clouds are, right?
Yep, and that's where.
If you look outside, you can see a bunch right now.
So those high wispy clouds. So it's literally called the high clouds, right? Least likely to contribute to structural icing. All right, that is a quote. The least likely to, it's a quote from the FAA. So there may be a reason why I made it on my slide. And these are the cirrus or cirro clouds. So cirrocumulus, cirrostratus. You don't see, doesn't say cirronimbus. You know what nimbus clouds are?
Rain clouds.
Why would they not be rain clouds?
Too cold.
Because they're a bunch of ice crystals, too cold, and it's not conducive to making rain. All right. So then the middle clouds. You may know what the bases are for middle clouds.
I think I do. I think it's 6,000 or 6,500 feet.
So about what?
Probably to about 16,500.
Actually, they overlap. So 16.5 to 23. Okay. So knowing that the big deal with these high clouds was that they're mostly ice crystals, what do we think is the big deal with middle clouds?
Icing?
They can turn into ice pretty easy on your aircraft.
Because they're primarily supercooled water. That's, again, FAA talk. So altostratus, altocumulus, and nimbostratus. So nimbostratus are rain clouds. But they're big, flat, layered. Stratus means layers. So they're those clouds that look like a layer cake kind of thing. So now they're conducive to icing. They've got supercooled water droplets. So from an IFR perspective, though, what's important to understand about them?
Super cold's gonna likely cause icing.
Absolutely.
They're stable.
They tend to be stable. They tend to stay in one place. They also tend to be fairly thin. So you have a much more likely ability to climb through them or descend through them in a reasonable amount of time to get to clear air. All right, they build in layers, and sometimes there's more than one layer. But Dylan and I, was that last night? I get lost. Last night or yesterday, when we went flying, he spent some time in the clouds, and we would pick up trace icing. What happened when we came out of the clouds?
Quit picking it up.
When
When we drop down through.
No, when we were up high and we would go into them, we'd pick up some icing, and we'd come out. What would happen when we get in the sunshine? They would thaw off. It comes off the tires really fast. It gets on the tires fast. Comes off the tires fast because they're black. And if you get into sunshine, you're not going to get into warm air. That's not what's really happening when you're up above, but you're getting out of the moisture. All right. All right. Low cloud. Jesus. So low clouds: stratus, stratocumulus, and fairweather cumulus. Almost entirely water, might be supercooled, might not. This is what you're usually flying in if you're in a 172 with no anti-icing and you're actually in the clouds. There's not a lot of icing. If there's snow and ice, the snow and ice will not contribute to structural icing. It has to be liquid water that freezes to the aircraft. And the bases are from the surface to 6,500. They only contribute icing based on outside air temperature. And that is near or below freezing. Right? And 5 degrees centigrade is kind of the upper end of when they say you might pick up icing. So, and how can it be above freezing? How can the temperature be above freezing and we get icing?
Inverted?
Because we're
moving through the air, cooling down the airplane.
So, in other words, when it's 5 degrees outside here in the middle of winter, that's a good time to go fly in the clouds.
Yes.
What?
Or when it's negative 26 here, it's a good time to fly in the clouds.
When it gets really cold because
You know
you have snow and ice, those sorts of things.
Yeah, right.
5 degrees is probably a bad play. And you'll see when we talk about weather products tomorrow. What's that?
5 degrees Fahrenheit.
Yeah, still not good.
Still not good.
No.
Oh,
It can be colder than that.
32 is 0. 5 is pretty cold. 5 degrees Fahrenheit would be all right.
Yeah, you probably don't get much ice if it's that
So-
cold, right?
Now we picked up some ice at 5 Fahrenheit when we were flying. So
What is the test? In our private, it says you can pick up icing anywhere from, I think it's 5 degrees to like 70 degrees Fahrenheit.
that's carb icing.
That's carbon. That's
I don't have a magic number for you right now. Remind me, and I'll see if there is one that they like for their questions.
Okay.
All right. So what is a cloud with extensive vertical development? What does that mean to you?
Thunderstorm.
Right. People are saying thunderstorms. Right. So what do we call those clouds before they become thunderstorms?
TCU. The towering cumulus cloud.
There you go.
Charlie Bravo's.
CBs, okay, usually contain supercooled water above the freezing level. Okay. Bases range from about 1,000 feet to 10,000 feet. Now that's the bottom of them, and then they go up. General rule of thumb, the taller a towering cumulus cloud is, the rougher it is. Also, the faster it forms, the rougher it is. Because it is completely made by the lifting action and large volumes of moisture. All right? Those are the key ingredients. All right.
What if you're on a 9-hour flight plan and you come out, you're just flying, and you see a big towering cumulus cloud start to form? Would they tell you to move, or would you tell them first?
Well, they can't see clouds.
That's what I'm thinking. So you tell them, I see this, and
Yeah.
okay, so you're allowed to do that.
Yeah, you can ask to divert for thunderstorms.
And flying over or under one is not a good idea in a 172, correct?
Over, under, or through a big towering cloud are all probably bad choices. If you can avoid it, and sometimes you do, not thunderstorms, that's a different environment, but big white puffy clouds, especially if they're just starting, sometimes it's just easier and faster to go through them. But as at least 2 people said, when you are on an IFR flight plan, that plan is not locked in stone, and you'll request to divert. And there's different ways you can divert. The most common one is you'll say, hey, I'd like to turn 10 degrees to avoid weather in front of me. And ATC will say, diversion approved. You turn right 10 degrees or left 10 degrees, whichever one you negotiated out, and you fly that way. Back to your question, though, you said, or will they tell me? If you have bad weather ahead of you, they will often come on and give you warnings if it's stuff that shows up on their scope. Now, somebody back here said clouds don't show up on radar. That is 100% accurate. Only things that can reflect radar show up on radar, so it has to be rain, snow, and snow doesn't always show up well.
Yeah.
Yep. But, so, light hail will sometimes not show up. Light hail. Heavy hail will definitely show up. But their returns show what they're called intensities. And so they will tell you if there's like heavy rain in front of you, light rain in front of you, those kinds of things. They expect you to let them know if you need to divert around it or not. All right? One thing that caught me off guard switching from like 172s and up to a 340, every warning I've ever had now about weather, except on one leg, I've just flown over the top of it. At 24,000 feet, you're over the top of all those rainstorms and crap like that that are beating people up on the ground. There was a night of horrible, horrible weather down in Louisiana. I didn't have to deal with any of it until I was ready to land. And I must have gotten warnings every 10 minutes about heavy thunderstorms ahead of me, heavy thunderstorms. But they all ended like at 14,000 feet. So, all right. 172. What's that? Yeah, 172. You're not at 22,000 feet, 24,000 feet. So the whole reason that we go to get our instrument rating, somebody said earlier, is to fly in clouds, which is good. But remember, some clouds have teeth.
Andrew, that's gonna be your Halloween costume this year.
Okay.
There you go.
Make it, I'll wear it.
Okay.
IFR's Bane, right there.
Did you generate that with ChatGPT or something?
Somebody else did. I just stole it.
You start the angry cloud.
Confusion. ChatGPT is
Cursed
excellent.
image.
I think I Googled clouds and teeth. But I throw it up here because this is the thing. Just because you have an IFR rating doesn't mean you can launch into any clouds. All right? And your IFR rating will need other things to make different clouds viable for you to fly through. All right?
Like, because your 340 has Speaky, right?
Yes.
So that helps you out.
And what's Speaky?
Flight into known icing.
Exactly. So my 340 is equipped with both de-ice and anti-ice. All right. What is the difference between de-ice and anti-ice?
De-ice removes ice after you've got it. Anti-ice tries to keep you from acquiring ice.
Okay. And we're going a little off script right now, but since we're on this topic, what ice mitigation equipment do we have on 19 or 69 or 8?
Veto heat.
Veto heat. Carb heat.
That's it, right?
And that's it. Okay?
No, we have the,
Oh, alternate air.
no, I was going to say you have the control lock and just scrape the windshield. Stick your hand out there.
If you light the engine on fire, that's gotta help in some way.
You would think, oh, you do have defrost.
And prayer.
Where you've got heat and
I don't think that counts as defrost though.
Breathing.
Doesn't it have defrost vents?
No, because it comes from your feet.
Well, it also comes from over top.
Over the top is supposed to help the front. My point is, number one, on your practical test, you have got to be able to specifically say the only ice mitigation that we have is pitot heat and carb heat. All right, that's what you got. And we use carb heat as a anti-ice measure primarily. Why do we use it as anti-ice?
You apply it before it gets on.
If you wait till your carburetor is iced up and cut it on, it's still probably not going to do anything. So, once it's fully blocked with ice. So,
then you're headed down the right path of what I'm trying to get at here is.
If it ices up so bad, your engine's gonna quit.
And when your engine quits,
so does your heat.
Your carb heat no longer works because it runs off of the exhaust. So you have to use it as a preventative anti-ice measure. Pitot heat, we use it in a preventative measure, so we use it as an anti-ice. It can be a de-ice, but it's easy to overwhelm a pitot tube, the heating element. Good question from Dylan while we were flying. Oh no, it wasn't from Dylan, from you. So, what happens if you leave the pitot heat on?
That'd be a good question.
After it's done.
Is that?
Melts the pitot tube.
Well, it can melt the, heard from Dave, it can melt the connection to the back where it touches the metal.
Okay.
Or where the wire
That actually
goes
happened
into
to
it.
Dave.
What's that?
Fire.
It caught on fire?
Yeah.
So, typically though, that only happens if you're sitting on the ground.
Or a really steep angle.
Yeah, well, you just need, if you have air moving over it, it cools it enough to keep it from overheating. But if you're sitting on the ground and you turn the pitot heat on and you leave it on, you'll either burn out the pitot tube, burn out the element, damage the wiring, or in Dave's case, apparently catch it on fire. But
Interesting.
so
I think.
as you move up, in fact, I had my plane out yesterday, and this morning. No, I just put it back this morning. I almost left it out so we could go out and walk around it, because then we could talk about anti-ice and de-ice and what a full plane has. But so what other tools do you see on bigger planes?
Boots. And
Boots, everybody okay, boots? What are boots?
Little things in the wing that expand, rubber boots pop out with compressed air, they kick out. Compressed air and break ice on.
It's funny because they don't kick out very fast. So they just inflate. And then they're usually scalloped so that when they inflate, they become ridge-shaped. And then when they come back, so the vacuum pump, the same thing that drives your gyros, provides the air. They just take it on the blow side, and that's what fills it up. And then it flips it over and it puts it on the vacuum side, and that's what holds that rubber boot back solid against the leading edge of the wing. And those are de-ice. They are designed that you get some ice, and they break it, and it sheds it. And there's been a huge change in how people have been instructed to use them.
Yeah.
So old school it was you had to wait until it built up so that you had enough ice for the bridge to break. The new answer is the minute you see ice, cycle the boots, keep cycling the boots, cycle the boots after you shed the ice. Yeah, number one, it doesn't hurt them at all. They just inflate them. We also, what people may not know is that boots are especially treated. We clean them with special cleaners, and then we put a treatment on them that makes them hydrophobic, which means
water doesn't stick to them?
Yeah, they're afraid of water. Hydrophobic. Yeah, water doesn't stick to them, so the ice sheds better. All right. Another thing you do if you fly a plane that you're going to fly into icing is make sure it's waxed. They shed ice better. They're less likely to collect ice, and then when that ice breaks off the leading edge, it peels further back. All right. So we talked about boots. What else do we have?
Heating leading edge elements on all your leading edges, including those on your tops.
Okay, you're going to take that in two pieces. Bigger planes, especially turbines and turbojets, will sometimes heat the leading edges of the wings instead of using boots. So that is an anti-ice system more than a de-ice. It will de-ice, but they're made to stop it from ever starting. They also use that heat around the inlet ducts on the engines so that the inlet ducts don't get ice. Let's see, and then like you said, not every model will have it on every leading edge, but they will have them on leading edges.
There's also Weeping Wings.
Is it that's that the awful like little liquid thing that comes out of the
Kind of messy.
Yeah.
And it's very heavy.
Yeah.
Fluid.
The fluid, yeah. So it's called glycol. So glycol, it's a form of sugar, really. It's antifreeze. And so the antifreeze comes out tiny, tiny holes drilled in the leading edge. It's forced out under pressure. It seeps along the leading edge. It's messy and sticky. But it's super effective, especially in heavy icing. What's the downside to Weeping Wings?
You can run out of it.
You can run out of fluid. And the fluid's heavy. It adds, it takes from your...
11 pounds or so.
Is it 11 pounds a gallon?
Yeah.
What's it called?
So it's TKS.
And you have TKS, your glycol.
Does that sound right, Britzel? Is it about 11 pounds?
I don't know. I've never had to play with it.
Yeah, nobody in this room has seen a plane without. Well, that actually might be a true statement. What's that?
It's heavier than gas.
This one says 9.2 pounds per gallon.
Well, gas is 6 per gallon. So every gallon of glycol you take, that's a gallon and a half of gas you can't. Just think of it that way. All right. There are also turbines and turboprops. They use bleed air off of the turbine system to heat those things. You also have electrical leading edge. So it's just like a heater that is taped to the front of your leading edge. And then the propellers on my plane have electric leading edge heating elements. Those, you will damage them if you leave them on for too long on the ground. There's a test you have to do every year where you actually, while the engine's off, you turn them on and somebody has to go up and feel them. And it specifically tells you to do it with 2 people so that you can turn them on and the person up front can feel and make sure they're heating, and then you turn them off immediately. You do not have time to walk around and check them because you'll damage them.
Why aren't those all the way to the pro?
Partly balance. They're kind of bulky because they got to have thickness to have the heating element in them. And as the prop spins, you heat up that inner piece and it slings everything off. If you look at planes that have done a lot of heavy ice flying,
the sides of the plane are like chipped from paint.
or big dings in that, because they'll fling that ice into the side of the plane. It's right about where the on my plane, it's right about where the baggage doors are on the nose baggage compartment. So we talked about.
If I'm correct, does it work one propeller blade at a time?
Yeah, they cycle around. And it's a balanced order. It depends on how many blades you have. In fact, I think it's one at a time on each, one on a time, separated by both. So like it's one blade over here, then it's one blade over here, then it's one blade over here, and it's one blade over here.
So that's a bit of a drawing electrical system already.
Yeah, it actually has its own meter, and that's how you know it's working, because it'll go tick, 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 tick as it cycles through. So we talked about propellers, talked about leading edges, tail edges. We'll have, sometimes the leading edge has one system and the tail edge has a different system because it's hard to duct the heat back there or whatever they want to do. We talk about heated edges, weeping wings, and boots. And then, okay, you're used to having a pitot heater. My plane also has static heaters. And I have 2 static ports. I have one on the left side and one on the right side, and they are plumbed together. That way, you're just, you also, instead of having carb heat, mine's a turboprop. It's not turboprop. Mine is a turbo supercharged engine. And it's a fuel injected engine, so I don't have carb heat, but I do have an alternate air source in case the primary air source becomes clogged by ice. And on some airplanes, that's automatic. It's a spring-loaded magnetic catch On mine, it's actually, you have to mechanically open a gate to get air to come in, but it comes, the problem with that is it becomes unfiltered air. Comes in a different route. But, so, those things are all built to give us ways to deal with ice. Alright. Alright, let's move on to life cycle of a thunderstorm. And I know at least 3 people in this room that better have this.
It's been a while.
Well, then I'm starting with you, Josh. Alright, how many stages are there?
There's 3.
And stage number 1.
I know 2 and 3.
You trying to negotiate it with me?
What's just wild guess?
Give me numbers 2 and 3.
Dissipating's 3. What would the first one do? Creating.
It's the cumulus stage.
Cumulus!
Yeah.
It's named after the damn cloud. So it starts out as a cumulus cloud. Cumulus clouds become thunderstorms. What's up, Mir?
I was going to name the second stage if you can't.
No, you should really do it.
You really should, because he's not going to get there.
Mature?
Yeah.
There you go. So it's so it starts out as a puppy little.
Cute little thunder.
And then every time it's mature, you just like.
So we start off with a cumulus cloud. That cumulus cloud starts to grow. It gets lifting action of some kind.
And accumulates.
Part of what happens is, so that's building. When it's building, it's mostly, which way is the wind going? Anybody know? Updrafts. Okay, what happens in those updrafts that contributes to the thunderstorm?
Your air starts cooling.
What's that?
Your air starts cooling the way up.
So actually, the rain falls down inside the cloud and then gets blown back up. And that water drops want to cling to something, so they cling to each other, and they get bigger and bigger and bigger. The other thing that is happening, and I don't know if this is even in the books, is that all the material in the cloud, the dust, the water, and all that, is rubbing against each other, and that's what starts building the static electricity in the clouds. But so it picks it up, updraft, updraft, updraft. You've got unstable air, so as the air goes up, it gets to a point where it's self-rising because it's warm enough that it just climbs through. They talk about you have to have enough moisture because the moisture is the energy. All right. So your building stage, continuous updrafts, everything's going, and then you reach a tipping point, and what happens?
Rainfall.
Rainfall, and at rainfall, that is now mature. All right. So you've got a mix. There's
The start of rain.
So the start of rain, and then you've got a mix of updrafts and downdrafts. All right? And that churn causes the rain to continue to grow, because it causes it to be heavier, larger droplets. All right? And during the mature stage, that's when the thunderstorm is the most intense. This is not on my slide, but how far do we stay away from thunderstorms?
10 miles.
Double it.
27.
So you want to stay 20 miles away from thunderstorms. All right?
At least 30.
How much is that? 30 IQ points? He did successfully double it, so we'll give him credit there. All right. So, and then it rains pretty hard. And then what happens?
Hammerhead. Forge.
Okay, that's part of it.
And
The anvil.
I
Yep.
know, I was thinking Hammerhead. I don't know why.
All right. So what I would say is think that what goes up must come down. Becomes a lot of downdrafts. It rains itself out. All right. So it runs out of water. It runs out of energy. All right. Most thunderstorms, how long do they really last?
7 minutes.
15?
15 minutes to half an hour. All right. So on those nights when there's like thunderstorms for hours, what's actually going on?
Cluster.
What's
Well,
that?
the building force
Cluster.
just keeps building more, and it moves over here, picks another one, and this one moves over here. And
Yep, so it's more than one storm, and they're at different phases at the same time. That's what happens during the summer. You get all this different uneven stuff, and you get lots of warm air down towards the ground, and it's in the afternoons, and then stuff just starts going up in the air, and once it sets off, and it can run for hours. But an individual thunderstorm typically only lasts about a half an hour. All right. Guarantee you that at some point you're going to get asked questions about thunderstorms. This is instrument flying, all right? So, we're supposed to stay 20 miles away from thunderstorms. How do we stay 20 miles away from thunderstorms?
Direct to and use the DME.
what about when the thunderstorm moves?
The DME will move.
Fly an arc around it.
This is why we learn how to fly DME.
That's what they're looking for.
Take your hunting rangefinder with you.
The short answer is look. Look outside. Now, modern era, you can also pull up XM satellite weather. You can pull up ADS-B input weather. What's the problem with that?
Like 10 minutes old, so you can only use it for kind of strategically avoiding large areas. You should not use it to pick between individual storms and try to thread the needle.
And the only thing I would tweak with that is it is at least 5 to 7 minutes old. It could be as old as 40 minutes. Okay? What's that?
Yeah, definitely don't trust that.
But the creation time is on there. It tells you how old it is. What it can do is it can give you a hint of, can I go north or can I go south? What way is everything moving? Those kinds of things. Yeah. Strategic, long-term, big picture planning, not tactical, small knife fight planning. Okay? So what tools do we have available to us to do knife fight planning?
Remember this from Velocity, there are little lightning indicators that will show you where lightning strikes are happening, so you can at least avoid lightning.
Literally called a strike finder.
Strike finder.
You know what those actually are? You're going to love this.
It's a little radio direction finding thing.
Exactly.
Yeah, it's awesome.
Lightning, it just happens to be that when lightning strikes, it gives off a radio frequency that falls into a very specific frequency range. And the strike finder just listens for that frequency to be someplace, and it distance and range finds it, and then it plots it on a little map. So lightning strike finders are one way we avoid lightning storms. You may know what's a weird thing that happens with them on the ground? If you turn on a lightning strike finder on the ground on most airports, it will go crazy thinking it's got false strikes everywhere.
There's all the radio signals.
Because of all the electrical equipment.
There's stuff built in under the lights up there.
All the power lines and the lights and the
VOR.
radio antennas and all that crap. So you'll see lightning strikes. So they tell you when you're on the ground to shut it off. And then if you're going to take off into bad weather, you actually turn it off. And then when you rotate, you reach over and you flip it back on so that it resets out. So just a weird thing. Okay. So now we talked about avoiding a thunderstorm. We talked about how sometimes you get a bunch of thunderstorms. And earlier somebody mentioned thunderstorms in clouds, which are called
embedded thunderstorms.
Embedded thunderstorms, all right? Now, we said you can't use ADS-B weather or XM weather to navigate those weather phenomena. So what do you have available to you?
ForeFlight.
ForeFlight? Well, ForeFlight is actually ADS-B weather in the plane. On the ground, it's just weather reports.
Weather briefer?
Not necessarily the weather briefer. I would say in the little plane, what do we have?
Oh, could you repeat the question? Sorry, my mind was elsewhere. Sorry. Something else.
You know, I actually called up because you looked right at me. Like you had something to say. And I was not deliberately setting you up.
Well, you turned around, so I looked at you.
There you go. So, with embedded thunderstorms, what tools do we have in 19 or 69 or 8 to deal with embedded thunderstorms?
Is the answer nothing? So
Yeah,
do
not
it?
anything that I can think of.
Radios?
Okay, what about the radios?
We can talk APC.
ATC has the ability to see some of that stuff. Alright, they're not gonna tactically thread you through something. They will help you if you need it. Like if you end up in trouble, they will help you. So what I do want you to know is CRM, alright, crew resource management. What we're hammering on is you are not alone even when you're alone. Alright? If you're the only person in the plane, you still have a radio. You can call and they have some weather radar. Now, don't go get yourself in trouble. If the weather reports that you've got like level 4 or level 5 weather in front of you, do not penetrate that weather. Even on the edges where it's like level 1 and level 2. Because when you read in Rod's book, they'll talk about how even if the outside edges look like they're healthy, you can expect level 4 anywhere within that storm system. So don't go into it. Right? If you don't have, okay, what kind of equipment could we have on board a plane that would allow us to fly into weather that might have embedded thunderstorms?
Radar.
On board weather radar. This is different than the radar picture that you get from XM or that you get from ADS-B. So my plane has weather radar. If you take off the nose of my plane, there is a dish on the front that literally goes side to side.
Very cool looking.
It scans side to side, and you can tilt it up and down. And it is a radar, and I can paint in front of me to look for returns. What am I going to get on those returns?
Moisture. Rain.
Rain.
Not
Clouds, but what I'm looking for is a thunderstorm. So I'm looking for
The intensity of the rain.
the intensity of the rain. All right? Now, if you have thunderstorms in a line, as always, awesome to see you.
Thank you. Have a fun class.
So when you're painting, if you get a big return here, you might not see a return behind it with another storm, all right? Because all the stuff gets reflected back. It's called a shadow, a radar shadow, but that is mounted on the plane. And that is how you can tactically avoid weather inside clouds that you cannot see.
On a side note, does that work for terrain avoidance or aircraft avoidance? Can you see aircraft or terrain with that?
You wouldn't see aircraft in any meaningful way because the resolution's too big and the rate is too slow. Does that make sense?
Yeah.
Like the plane would move too fast and it would, if you got any kind of return, it would just be a streak. You do use it to paint the ground. Partly you use that to figure out what is weather and what is not because you're supposed to know what kind of ground you have in front of you. So, but yeah, if you pointed at them, if I was flying in this way, and I can tilt it towards the ground, so when it's tilted at the ground, you kind of paint to the ground, and then you work your way up to figure out where the ground meets, and then you look for weather, and then you come up, and then like I said, we flew over weather. What we did do with the radar was I would look and find the storm cell that they were telling me about that was in front of me at the bottom, and then I'd paint up, and then watch it go away, and then I would just tell them, hey, I'm going to go over the top of that, I'm okay. And you just keep going. Because once you're over that, if it's super intense, then you know it's going to be super tall, and then you go a different route. All right, this is just a picture of the. I did start to throw more pictures in, and then frankly, I got done making slides, and I was just done making slides. So I don't have a bunch of pictures of the clouds. You have all seen the puffy cumulus and the flat stratus, and if you want to see more, GTS. Yeah, Google that shit. All right. But I do watch it. I like this one. You see the cumulus stage. It says like 3 to 5 miles in height. If your clouds are just a puffy ball of white cotton out there that's like 100 foot thick, that's not going to be anything that causes you a bad day. We flew through those the other day. They don't even register. But if you see that it's getting to be about 3 to 5 miles tall, that's going to be weather. Because it's got the energy to grow. What's funny is you will also very often see glider pilots flying underneath that stuff and climbing in it because it's got
updrafts.
Lifts. Yeah.
Yeah, if you see the flat bottoms on those clouds, there's no draft there.
There you go. So, actually, that's a great point. I would have missed that entirely. The bottom of thunderstorms loses the puffy part. It looks flatter and smoother, but it has the bumps all around it going up. All right, uneven tops. Right here, and you see that shape there? Then you hit the mature stage, and this is, you see we got updrafts and downdrafts. And then dissipating, it's raining out. And I don't know why this picture doesn't have it, but it anvils out. The top of it just kind of trails off.
Because they're almost always moving across the ground at a good rate, too. There you go.
So, there you go, wind shear, turbulence. You can also get roll clouds on the edge.
Rotors.
Yep, rotors, roll clouds. You don't want to fly into those, especially at 172, because you can very, very, very quickly be upside down. All right. Now, this is not new. As private pilots, you are taught to avoid thunderstorms like the plague, right? What we're emphasizing here is all the rules about thunderstorms are the same. You cannot fly a plane into a thunderstorm and plan to come out the other side. Not a GA airplane.
The only difference being now as IFR pilots, there's a lot more of a chance of us accidentally flying into one if we're not being careful.
And what do you do if you accidentally fly into one?
182.
You slow down. Don't climb.
Alright.
Slow down, don't climb, turn around.
Well, don't you dive through?
Yeah, we covered this last.
Yeah, we did.
On where?
Well, we already had this question the other day. So what
Okay, there are two different school of thoughts. So, Jason Shapper from M0 Alpha will tell you to turn around. He also will tell you, before he tells you that you should turn around, that is not the conventional wisdom. Alright? It's one of the few things I disagree with Jason Shapper on.
Conventional wisdom would be to maintain the same attitude and fly it out.
Maintain the same attitude.
Not altitude.
Not altitude, not airspeed. You don't try to hold either of those. You let that plane go where it's going to go. You just put it into VA or slower. And you ride it through straight ahead. So what's the problem with turning around?
If you're moving with it, you're just going to sit there in it. Part of it, if it's moving. And you turn
Okay, I hadn't even thought of that, but it's, yeah, if you try to turn around and it's going the same direction. So if you penetrated it and it's coming towards you and then you turn.
You're spending that time in the turn as well outside the thunderstorm.
Well, what's the other thing that happens when you turn an airplane?
You slow it back. You slow it back. Yeah.
Okay, and if you turn 60 degrees, how much is the increase in load factor?
2.0.
Double, all right? So 30 degrees, it's actually what, like 1.3, something like that, times. It is a logarithmic curve, it's not straight. But the point is, what you're trying to avoid is structural damage. What happens if your airplane gets struck by lightning?
Depends on where it is.
Probably not much. At most, you will get like a burn, maybe a hole, and on extremely rare occasions, you'll lose your electrical equipment. But extremely rare. Why is it extremely rare, Tristan?
Because your aircraft's not grounded.
Well, and because they also designed the aircraft to shed electricity on the skin. In fact, you've got these little wicks coming off the back. So we have
They're more on the 182s. I don't think they're on the 172.
172s may not have them, but like if you get on bigger planes, you'll have little wicks that come off.
I've seen that in the 182.
Static wicks.
They're called static wicks, and what happens is the electricity literally jumps off of those wicks, and that way it doesn't. They're built so they don't burn parts of your skin on your plane.
How does that work with composite skin aircraft? Just
They actually literally run electrical wires throughout the composite skin to give a conductive path. Great question, though. And look, I actually know the answer. I did not know the answer to that until I became an AP. Okay.
I believe if you've been on an airline flight, you've likely been in an aircraft struck by lightning.
Yeah, it's
On average, happens to all of them once a year.
every plane, all those guys get struck. Alright. So what I'm getting at here is the thunderstorms, the dangerous part is not the lightning. It's the turbulence. It is the rapid changing directions of air that cause you a bad day. Okay, so what are the ingredients for a thunderstorm?
Uplifting action, sufficient water vapor. That's all about it.
There's one more.
Yeah.
It's always one you miss. What is it?
It's unstable lapse rate.
Yeah.
You are 100% right. Sufficient moisture, unstable lapse rate, and a lifting action. What are common lifting actions?
Orographic.
Which is?
Topology where wind is blowing stuff up the side of the hill.
Thermals?
Mm-hmm. So, thermal lifting.
Fronts.
Fronts, which is kind of like orographic, but it's air masses instead of land.
I was gonna say cold fronts specifically.
Yeah.
I think it's.
But two fronts that hit each other, one of them is going to go up. All right? So you've got frontal lifting, you've got orographic. I don't even have that on a slide. I just, as we're talking about lifting action, like what makes it go up? So if wind pushes a moisture-laden mass of air up a hill, what happens if it's a stable lapse rate?
Just stay there.
Yeah, that's it. It will go up as far as the wind pushes it, and then it'll just come back down. You might end up with like ground fog, crap like that. But what you have to have is an unstable lapse rate, something that once it gets moving, and then it starts to rise, it just keeps rising. And then that's why these clouds get up to the 40 and 50,000 foot range. Now those are big thunderstorms.
It's particularly like if you have an inversion layer and you've got warmer air down below and it gets shoved up through that inversion layer.
Yeah, the problem with inversions is that usually there's very, very stable air sitting on top of them. So what you end up with then very often is just a layer of haze or fog, a cloud layer. All right. So, all right. What is something that thunderstorms always have?
Lightning.
And?
Thunder.
Lightning and thunder.
Oh, they.
What's that?
And you kind of need.
Yeah, but this is an FAA question.
So it's not, the aspect is not always rain, right?
No, because you can
It's
have,
always
a
lightning.
storm in the desert, and
Yeah.
it'll actually evaporate before it actually makes it out.
So what's that called?
Sad.
Dirt sandstorm.
Actually, it's really cool to see.
It's Virga.
Virga is rainfall that never hits the ground. It evaporates and goes back up.
Actually, you see it all the time. Like, a lot.
Especially up in the air. Like it's easier to see when you're up in the air and you're like, oh, yeah, it looks like it's raining over there but not down there. Let's see.
All those times.
Okay, and a weird one. So lightning strikes are most likely when the temperature, outside air temperature is between -5 and +5 degrees Celsius. I don't have a clue, but I do know that that is the right answer to a question on the test.
Okay.
Without it.
5.
I don't know. It was a rabbit hole that I forced myself not to go down.
Because cold is scary, so lightning has to be.
So, and then orographic lifting cools air that is forced up by terrain. We talked about that already. And upward currents enhance the growth rate of precipitation. We talked about that already. What happens is the drops kind of fall down, they get picked back up, they run into more water, it clings together. Water is a cohesive liquid, which means water likes to stick to water up until it reaches a mass where it exceeds the ability of the surface tension to hold it together. All right. All right. Nicole has already mentioned this several times. Airborne weather radar and I'm just gonna expand that, all weather radar detects precipitation, not clouds.
So it would detect like moisture inside a cloud. It's not necessarily precipitating. Only the precipitation.
The moisture has to be dense enough to reflect. So like Virgo would give a return because those are water drops. But there has to be like drops of water. But it does not detect clouds. All right? How do we see clouds and determine what kind of clouds we have available to us in the weather products that we get? And we're not doing weather products today, but
A little, if it's ground based, like sky coverage things, aren't there lasers or something weird? Shoot out.
I think they're called transmissometers.
Yeah.
They're reflective transmissometers now. They shoot out, they put out light, and then they have a sensor that measures the ambient light, and it measures how much light comes back. And how long it takes.
Fun fact, the visibility for our airport here is literally a emitter and a receiver so far apart.
Mm-hmm.
And it shoots basically a laser through it and measures the degradation of the laser.
Which is why when Andrew's over there mowing, sometimes you'll see like quarter-mile visibility. And then blue sky and no clouds.
And if all of a sudden that you see a constant of quarter-mile visibility after Andrew mows, you can guess what happened.
That he hit it?
Or
That's
that.
a mower stranded out there.
So, I was headed towards, we use overhead imagery. They literally take, the satellite images, and they use multispectral imagery to determine how dense the clouds are, where the cloud heights are, those kinds of things. But that's not done with radar. It's done with multispectral imagery.
So we're in Ghostbusters.
That's right.
That's really weird.
All right, we already talked about this one. Thunderstorm penetration. All right, fly at maneuvering speed unless a turbulent speed is given to you. Maintain a level altitude. Altitude and airspeed may vary wildly. By the way, that may be on a question. May vary wildly. Let it go. You just got to ride it out the other side.
Would it theoretically be possible to exceed V&E in a thunderstorm?
It would, and it would cause structural damage.
I
Joe,
had one, I forget who it was, but they had like one draft that hit one of the wings and they went, fell straight down pretty much.
How do you fly a VA if your airspeed?
That's what I was
Because you start there.
You start pulling power back and you start trying to slow down.
Set up a stabilized.
Yeah, so don't aim for VA. If your airspeed is going up and down by 20 knots, aim for 20 below VA, but still 20 above stall speed, so that you don't end up doing either one of those bad things. If you want to hear what happens, there was an accident just less than a year ago where a CFI took a student on a night cross country, and they were flying back, and this guy was a dick. He was like, oh, I've never seen anybody pre-flight as slowly as this student.
The Snapchat one!
Yeah, the
Those were so sad!
Right, but what happened is, the dude's like, I want to get home, and he just took the student right into a bunch of thunderstorms, and they got the wings flipped off and died. I mean, so it happens. Thunderstorms suck. Don't do it.
Also, texting nasty things about your student is just stupid.
That was
That's-
determined he was a bad guy.
Very unprofessional.
Yeah, well, he was 21. The flight instructor was 21.
Yeah.
He was immature.
It's me, guys.
What's that?
It's me. I haven't posted about you guys in so
21-year-olds are more mature than others.
Yeah. Thank you.
And some are dissipated.
All right.
There's
But if I
31
remember
year olds who are
correctly, they went into
less
like
mature than
IMC, and then he took control, got a pop up, and
Yeah.
then they crashed.
Yeah, got it off and then went ahead and went right through the thunderstorm area anyway. Yeah. They had so many chances to
To not do
to
that.
live. Yeah.
There's a word for people like that, but I don't want to say it on screen.
Thank you.
It's all good. What that does bring up, though, is as students, if your instructor is asking you to do something that you do not think is safe, say no. All right? Yeah, I am not comfortable with that. I would like a second opinion. Now, we're going to push you. I mean, that's our job, is to help push you past discomfort. But it doesn't do any good for you to be scared. And it doesn't do any good to put anybody in a position of risk. All right? So, I can tell you that here at Northern Air, Dave's not going to put up with flight instructors having you do dumb things to do dumb things. I will also tell you that Dave is more than willing to push people's limits.
I do things that'll scare the sleep out of you.
Okay. So, but not long ago, Nicole and I we took Dave to go pick up a plane. And the entire day it was a big debate back and forth. It was pretty scuzzy, required flying kind of low. Just, how you doing?
Doing really good.
No Timbits this time?
Wow. No Timbits. You guys got chocolates, right? I would have brought some. I didn't know you guys were.
It's IFR ground school.
Oh, my ground school?
You gotta join the class.
There you go.
Oh, I could, yeah. I think I really go 40.
Good plan.
Yeah.
Have a good one. So, but yeah, both Nicole and I that day did flying that we were like, I don't know, this kind of pushes my edge. But at the same time, you can say no.
Well, I think I did on one of them. It was like, take this corridor. I'm like, no, that's past my limit.
Actually, that's a great example. Dave was like, yeah, we can go up this way. She was flying the plane. She goes, I'm not. That's past my limit. I'm not going there. Okay.
And we still made it to the destination without being on the news station.
Exactly.
You can always find another flight instructor. You can always find another flight school.
Mm-hmm.
Can't find another life. So.
Marketing, Alex.
All right.
It's not pretty good marketing for you. You can always find another flight school.
I've always said that I'd be a horrible business owner.
Or an excellent one. I mean, I think that the whole point is here, what we would rather have you do is speak up and say, hey, I don't like that. I don't trust that. I don't feel that. All right, we'll figure out something different.
But Dave is also not so afraid of liability like some places that he will let you learn. Right?
A great example is we land on grass.
Yeah.
This flight school flies to airfields that we land at Kavanaugh, we land at Port Hill.
Yeah.
And where?
Like Troy and stuff, but it's Eckerd.
Yeah, the guy that took me there kept going to Port Hill, and now it's stuck in my head.
Troy's not grass. It's like
But Troy's is rough, and you're mowing
potholes. I don't even know what that's supposed to
You
be.
got to mow the field with the propeller as you're going.
First there.
But have a good one.
Tony, did I give you a map of the airport? You know where you're going?
No.
Okay.
I was going to go hunt around there.
Here, let's go up and go check the
Apparently
office.
you stole my plane.
I'm sorry. Here.
I gotta go find it.
It's like hide the seat
All right.
Cessna.
So we're going to air masses. An air mass is a body of air that has fairly uniform moisture and temperature. All right?
Man, we should have just required everyone to come to that, like, the last 2 weeks of the private ground school.
I know.
Yeah, we could have saved time. All right. Except, I think we're going to get a little bit of some tweaks down here. So maritime tropical. All right. We're talking about air masses, and in the book, it'll talk about maritime tropical, continental, polar. All right. It's actually, there's maritime, continental, polar, and tropical, and you can just put those together. All right. Maritime means it forms over water. Continental means it forms over dirt. Tropical means it formed in the tropics or further south. Polar means it formed closer to the poles. All right. So if we look in the northern pole, so this CA is actually continental Arctic. Then you got continental polar. This is marine polar, or maritime polar, maritime polar, maritime tropic, and continental tropic. Okay? If you notice, they're kind of in three blobs. There's a blob on the top of the pole. Then there's this blob around here. And then there's a blob that's just north of the equator.
So it's always going to be two of those, right? It's going to be not just continental. It's obviously not just continental. It's where it is this way and what is over.
Yeah, what did it form over and where did it come from?
What's the dividing point between polar and tropical?
So it tends to be where those winds kind of do that circle. If you remember.
About every 30 degrees.
Yeah, the wind patterns.
So from here to about 30 degrees, and then from 30 to 60, and then above 60 to 90 degrees. So 90 degrees is the pole, right?
So anything that forms over us is going to be polar?
Well, yeah, we're actually just north of the 30 degree parallel, right? What are we, 40?
Or 40 something.
We're like 49?
48.
Want to look on that?
Well, don't we have a ski resort around here called 49 degrees north?
47.
You're a little bit off.
Are they?
Yeah.
That's fine. So do you know where we are up here? I don't know if I'm
I'm pretty sure it's.
So we're 48.
Yeah.
48, 49 area.
Yeah.
Right under the 49.
degrees.
49 is like the polar
Okay.
action. So.
But so that puts us, we're kind of in the polar region. All right. So, but what really happens is, like over Canada, north, up in here, you get this continental polar development. You get this marine polar development, and you'll see it all kind of pushes in on us. All right. It's just and the air masses, like at the tropics, they rise up, they move north, and then they sink back down about 30 degrees. So a little bit south of us. And a little bit south of us, there's air rising up, moves over us, and then a little bit north of us, it drops back down. All right? That's the general gist of the big air masses. Now, what do we call the area where two air masses run into each other? What's that? It's a front. All right? So, and then fronts move, usually. So, this little line with the buck teeth, that's the indication of a cold front. Cold fronts have teeth. Cold fronts also bring bad weather. Am I doing all right so far?
Yeah, because it bites you. Cuts in underneath.
Cuts in underneath. It'll lift up. It's denser air, so it tends to lift up warm air. So we're going to move. Does anybody remember what the four kinds of fronts are? Go ahead with the question.
A cold front is a cold front by nature of the fact that it's colder than the air it is encountering. So it could still be quite warm as far as the air temperature, correct?
Yeah, it could be 90 degrees.
Yeah, it's all relative.
98 and fine.
Yeah, it's all relative. And whether it's a cold front versus a warm front is which one's moving, which one's displacing the other. Okay? Your question?
Nothing. He's asked if we knew what four kinds of fronts were.
What are the four kinds of fronts?
Warm, cold, stationary, and occluded.
Absolutely. What? Okay.
Been waiting for that one.
What is an occluded front?
An occluded front is a cold front and a warm front. Well, no, it's a cold front chasing a warm front, where they're at the same point, right?
So it's any front that catches up to another front and picks it up. They're typically cold fronts, but you can have a warm front that is an occluded warm front.
A warm front occlusion.
Yep.
Gotcha.
So, all right.
Yes.
You absolutely need to know these symbols. The teeth point in the direction the cold front is moving. The nubs point in the direction a warm front is moving. All right. Stationary front isn't going anywhere, so they alternate. Also, if it's in color, usually a cold front's blue, warm front's red, and an occluded front will be purple. But an occluded front is moving. So you notice the teeth and the bumps point the same direction. If you see it in black and white, you should still be able to decipher. All right? So, cold front, cold air colder air
happens every time.
Should we plug that in for you?
I probably should. Okay. A front that moves in such a way that warm front which is stationary or nearly so. So, what are some of the traits of a cold front?
It's cold.
Technically, you want to use the word it's colder. Because it's what's that?
Wind sheet and swift moving.
It's worse weather than the warm front.
So it brings
in worse weather.
Got unstable air, right?
Unstable air.
It's faster.
It's cold air cutting underneath warm air, so it's causing a temperature.
Okay, and what can come in front of a cold front? What's that called?
Squall line.
There you go.
Oh,
pulling it out there, man. All right, cold fronts.
I don't know why.
So yeah, instability, turbulence, vertical cumulus. It has cold fronts give you lots of lifting action. So what they're picking up is warm air, and that warm, moist air that it picks up just keeps going. All right, showery precipitation. What do they mean by showery precipitation?
Drizzle. Every now and then it rains. And then it
Yeah,
stops.
rain, stop, rain, stop, rain, stop. And we've all seen that. Those days, during the summer where it rains for 5 minutes and then it quits raining and you're like, oh, it's going to get night, and then it doesn't. And then, oh, it's going to get, oh, and then it doesn't. Yeah, all right. All right. And widespread precipitation. So the rain is all over the place. Oh, I'm sorry. Wrong thing. That's warm. Read my wrong note. So squall lines. So squall lines are lines of thunderstorms. And you just think about that. If you've got a front that's moving along and shoving up a whole bunch of warm air, that warm air turns into thunderstorms, and it just keeps kind of going up on its own. That moves out in front of the front, and just crappy weather. All right. So then warm fronts. Oh wow.
Where does stuff like the Dust Bowl occur? Like, what kind of weather is that?
Well,
I'm sure that was an agricultural issue.
Yeah,
I got that part, but
well, so not to go down a rabbit hole, but so the Dust Bowl resulted due to overcropping, which then reduced the amount of root structures that were available to hold dirt down, which resulted in a lot of dust getting into the air. That dust, where that area was that had been overcropped, also then held heat differently than it did before.
Okay.
And so it would blow dust everywhere. And then once the dust gets in the air, you end up with these heavy particulates that are then able to collect moisture. It's just a cycle of bad decisions.
And it gained intensity, took out the East Coast.
So in the Army, we used to call that thing something like that a self-licking ice cream cone. It just makes itself worse.
So think about climate versus weather. Right? The Dust Bowl phenomenon was a change of climate, which is a longer-term phenomenon. They still had cold fronts and warm fronts and different things blowing through it in a given week, whatever the weather was. But the climate was really what changed.
And with that, let's take a 10-minute break.
Bill just had an ice encounter in the FBO.
Talking about rapid
icing. That was absolutely an academic display.
Is that clear or rhyme?
Yes. I think it's mixed a little bit.
No, it's lime.
It's lime.
It's lime ice.
It's rich people ice.
the dad jokes is new stuff.
Hey!
And Callie is the de-icing system. Well, she had been the anti-icing, but she wasn't fast enough.
Okay.
This is going down. Well, I owe you some entries, don't I?
Yeah, I'm getting my blue pen.
Yeah, we'll do it after.
Just pick it up, Callie, and put it on the night.
Here, your pocket.
Flip your shirt around, you got a little bucket.
That might be why they're single. Because I don't think she is single.
She's not. Me? No.
Yeah. There was an entirely inappropriate conversation going on.
Don't worry about it, Callie. I don't want to hear about it.
Yeah, you are not old enough for the
But I
conversation.
don't know what for me. It's not bad if we get a little bit of ice that melts on the carpet. I just didn't want to get all of this to melt on the carpet, so we should be fine.
So, Bill,
Mm-hmm.
I was gonna say if there's stuff you think like, because we were studying on Thursdays,
Mm-hmm.
like you guys should study this for next week, or you have specific questions you think we should go over or something. I'm gonna text this to me some pointer for Thursdays. Then I can make that part.
So we should all do this.
Where are we, Gary?
No rules.
What are we looking at? Half of last Thursday we were doing weather, and we're doing really well. We're like, you know what, we're just on last week, so let's do more.
I feel bad because you guys did all the work cleaning up my sodas.
Yeah, Bill.
But there's something specific you think of.
No, it's not like we deserve a reward. Right?
I think it's like.
I did buy her dinner. So.
And not me. I was here.
Why you weren't with us?
You're a loser.
Yeah.
Also, you totally missed the under there.
Yes.
Right here.
I mean, I've never met a pizza I didn't like, so.
Did you say you've never met a pizza you didn't like?
Yeah.
How much stuff?
Well, boy, you've led a sheltered life because I've eaten some crappy
I'm just, I'll let it.
Anything with anchovy?
Like, name one. I can eat it.
I had
Fish I have
eaten them for you.
Last broken.
One time I took a take and bake. We have a pizza oven, and he rolled it like a burrito. Who was the one time where he cooked the
Valley. Yeah, it's run blind.
cardboard on the bottom? What was that?
The instructions.
It tastes the same when you're done.
Well, so he did that first, and then he rolled it up like a burrito and unrolled it on the pizza stone. And it didn't work. It did not work.
I can't imagine why it didn't.
Yeah. It's sound logic there.
Pizza pie.
I did.
Because they make pie.
Yeah.
It doesn't make any sense. It's like a totally
They're
different
also
thing in my brain.
Golden, I know, golden pies.
Here's
That's
the
the
big we can talk about.
When the moon hits your eye like a big pizza pie, that's amore.
Types of food. Pie, soup, sandwiches, and pasta.
That's it.
There's 4 classes of food.
That's fair.
The 4 classes.
What were the 4
I was gonna
classes?
say the same thing. He
said there was
sandwich.
pie,
Sandwich.
sandwich,
Yeah.
soup,
Rice.
and pasta.
Where does salad fall?
I don't know, I've heard of lots and lots of arguments about, you know, what's the difference between a sandwich and a taco? And,
That's crazy.
you know, sandwich, a taco, a burrito. You know, is a hot dog a taco?
No.
Whoa.
Yes.
Yes, and a taco is a subset of sandwich where you have an open faced sandwich and you squish it.
Sure.
No, a taco you use a tortilla.
It's just stuff on it.
It's bread that's folded in half
With things in
around food.
It's a hot dog.
So a hot dog is a taco.
Yeah.
And a taco is a taco.
Alright, anyway.
What?
Alright, I still got quite a few slides to get through, so I gotta speed up. So,
Do you only pause first to clean up your mess?
oh yeah,
Yeah.
pretty much. Not that I was expecting you to clean up my mess, it's just that's what happened, and I let it keep going.
I mean,
It's called skating.
Alright,
Military types are good at it.
it actually be called shamming.
Shamming?
It's called shamming, S-H-A-M.
If you're gonna offend him, do it right.
Yeah. We have a rank in the Army, Specialist E4. We refer to their rank as a sham shield because they're all just in long enough to know how to get out of doing things, but they don't have enough authority to be in charge of doing things, and so they know how to disappear.
So basically, they don't do anything. They don't have to make anybody do anything either.
That's the goal.
I would end the goal.
Ah, your taxpayer.
All right.
Hard at work.
So we talked about cold fronts. They're marked by instability, turbulence, vertical cumulus. Bottom line is cold fronts bring crappy weather. All right. Warm fronts, though, they have a shallower slope. And now, correct me if I'm wrong on this.
Just kind of
They tend to stay there for a while. They tend to be longer lasting.
slow moving.
Yep, slow moving, long lasting, crappy weather. They have stable air. What do we get with stable air?
Crappy visibility.
There we go. Crappy visibility. You are right that we get stratiform clouds. But what happens, the reason they are stratiform is they don't get pushed up and they don't get broken up. And so...
It's because there is little to no wind.
So yeah. So warm fronts are also crappy weather, but a different kind of crappy. And it's not the... But it's the kind of crappy you can fly in if you have an instrument rating. You know, because less likely to have icing, less likely to have thunderstorms, those kinds of things. All right. Widespread precipitation. You will have wind shear before the front passes. So the wind will change direction. That's because it's this steep angle of air moving, and the air in the warm zone moves one direction, and the air in the colder zone moves a different direction. All right. So what kind of weather do we expect at a stationary front?
Probably not very good either.
Extremely bad weather. You get
The worst of both worlds.
But it can't really build because it's not really moving.
So
And they build because they move.
Mm-hmm. So, but what you do have is they can stick around for days. You can get some of those upbuilt thunderstorms. You're not likely to get the squall lines because, like Nicole said, it's not moving. It doesn't have the energy getting pushed into it. But you can get frontal waves, form on stationary fronts or slow-moving cold fronts. All right. And then an occluded front, it's typically a cold front catching up to a warm front, because cold fronts typically move faster than warm fronts. But it's not always. It can be a warm front catching up to another warm front and picking it up.
No, then that would make the other one.
What's that?
Front.
What's that?
So that would make the other one a cold front, right?
Well, it depends.
It's the air front of it.
Colder. But the bottom line is the air stacks up. All right? And you'll just get crappy weather, and it's not going to move very fast typically because the fronts are moving in the... I should rephrase that. The weather is going to stay crappy, but the crappy weather moves slowly because the occluded front keeps moving in a certain direction. And so if you have a crappy front here and it's headed south, today you can expect to have kind of crappy weather down in Spokane tomorrow morning, and then a little further south as until the occluded front breaks up. It's just going to keep moving, being crappy.
So you're better off flying in the opposite direction of the...
All right. And now at this point, I went through these slides so many times, I don't remember if I put lows and highs in here. So, oh yeah, I did. Sorry. It'll come up later. So jet streams. The FAA says a jet stream is 50 knots or greater. This is important because the FAA says a jet stream is 50 knots or greater on the test. This is not documented in any document in the FAA's library.
That would be too easy.
But it is a confirmed test question that they ask. Typically, they exceed 200 knots. So, you know, when you're looking at winds aloft forecasts, thank you. The strongest winds are at the core, so the wind in the middle moves faster than the wind around that, which moves faster than the wind around that, okay? It's not the whole big mass moving at 200 miles an hour There's different streams inside it.
So it's not like you're just going to be flying along, and all of a sudden half your aircraft's in 200-mile-an-hour winds and the other half your aircraft's in calm winds.
No, but there is wind shear and it does step quickly. And you're not going to see a lot of 200 knot winds at the altitudes we fly, but you can easily see 70 knot winds. Okay?
I want that.
Do you guys know that mathematically speaking, it is actually a fact that you will spend more time in in your entire flying career, you'll spend more time in a headwind than you spend in a tailwind?
Why is that?
Because life is not fair, so get over it. No, so if you've got a tailwind, and let's just say, I get up in the morning.
I see where you're going.
Yeah, because you spend more time with your tailwind, you get there faster.
You get there faster with the tailwind.
You turn around.
Then you turn around, you come back, and you end up in the headwind. It can easily make it twice or 3 times as long. It's the way it works. All right.
Why does that feel like a trick question?
That's what I'm saying.
Do you guys also feel slightly taken advantage of?
Yeah.
What's that?
It just feels like you're like, well, statistically, you're going to spend more time in a headwind. You're like, why? Because headwinds make you fly slower. I feel like it was going to be so much more than that.
Actually, it is that simple.
I know. I don't like it. My brain doesn't like it.
Financial advisors do the same thing. If you hear a retirement plan talking about dollar cost averaging, it's the same thing but with money.
So you're going to spend more time swimming against the strain? What?
No, if you buy a constant amount in dollars of stock and the market is going up or down, you will buy more shares when the market is down because the price is lower. You will buy fewer shares when the market is higher. And so you'll actually, by dollar cost averaging, you end up ahead. In this case, not behind, like with the tailwind, you actually end up ahead if you invest constant amounts starting when you're young and keeping it going until your retirement age.
There goes all my money. I'm going to start investing.
Yeah, totally.
Yeah, this is a life hack.
Don't throw it into the wind.
Invest in it.
That's literally what we're going to do.
Becomes a career. And then when you start having income from a career, then worry about retirement.
So the jet streams, they move. Now they typically blow from west to east over the United States. So you will more likely spend time when you're coming from the east to the west in a headwind. It's just the way the life works in the United States. During the winter, they are stronger and further south. And during the summer, they move further north. So some people actually, part of the reason they plan their trips during the summer is because they are less likely to have bad headwinds coming back. So it's not impossible, but you're less likely to have just crappy headwinds. Low jet level jet streams can be just a few thousand feet above the ground. I could not find a specific altitude, but so your low level jet streams, their answer was a few thousand. So in FAA speak, I would say that's somewhere around 8,000 feet.
So why are they called? Sorry, it's a dumb question. Maybe I missed it. Why are they called jet streams?
Because they are very fast moving streams of air.
Okay.
Oh, these aren't created by jets.
Nope.
How do jet streams? Do you think somewhere that jets fly?
Jet stream is a weather phenomenon.
So what did jets create? Like just
propulsion.
Contrails.
Condensation.
Okay. That for a minute I was like, wait, what causes it?
Wrong word. What's your pilot have signed it?
Jet stream. Okay, so the contrail. Oh, what causes the jet stream?
Yeah.
Uneven surface temperature changes, uneven heating of the earth. It's the air is constantly moving.
But
didn't have anything to do with Coriolis or anything like that.
It adds to the direction it goes. Yes.
What's that?
The circulation of the air adds to the direction the jet stream goes. So kind of like the east, like the westerlies and stuff like that. So when you like break up those 3 categories of wind, you know how we're talking about we have like that 30 and then the 60 and the 90. So how they circulate there, then the directions they try to move, because like there's elongated low pressures.
Yeah.
So that causes the directions to move.
Trade routes for sailing ships would just be jet streams. Trade routes for sailing ships would just be trade route or jet streams.
You are so far out of my wheelhouse, I don't have an answer. I have no idea how sailing ships pick their courses.
So the quick Wikipedia answer is jet streams are the product of two factors: atmospheric heating by solar radiation that produces large-scale polar, Ferrel, and Hadley circulation cells, and the action of the Coriolis force acting on those moving masses.
There you go. So the Earth's spinning and the uneven heating of the Earth, and we have jet streams. And they tend to go from the west to the east.
Because the Earth is spinning from the east to the west.
Probably.
Ah.
All right. So now we're going to change topics a little bit to isobars. And I should have put a picture in of this. I absolutely failed.
I'm just sitting there next to that.
What's that?
Having a conversation back here.
Would you like to share with the entire class?
No, Callie was just zoned out, sitting here giving Lucas the stink eye. You're like,
You were on my side for 3 seconds and then you both
Can we blame her? I mean, I'm pretty sure Lucas heard the stink eye, so. Alright. So, I know that you guys, I know these guys all over on this side of the room have looked at the isobars, and we're going to look at them next week, because next week is actually weather products. But they're lines of equal pressure. If they're close together, you have strong winds. If they're far apart, you don't. All right? Air moves from high to low. Air moves clockwise in a high. And I don't know, the way I remember that is high time. It's high time for something to happen, so the wind goes around clockwise. The answer I got somewhere else was, clockwise goes in a low, counterclockwise in a low because it goes to the left, low left.
it's like a screw line.
Mm-hmm. All right, and now suddenly my brain's going to hurt here. So if you have a high pressure area, the air goes down and out, making sure.
Because it's getting rid of the stuff at the bottom, and it's just going to replace them.
So it goes down, out, and clockwise.
And then it goes in and
up, and counterclockwise in a low. Okay? So, since you've been over there with your screw analogy, I'm going to assume you know the answers to these for your written test. All right. Coriolis force. This is not.
Oh, that's right.
Sorry, I have to answer a question for somebody right now.
Don't worry, they weren't paying attention anyway.
42.
I was gonna say 42. This feels like the time for a pop quiz.
42. Yeah.
Oh, speaking of pop.
So, we always talk about the Coriolis force and say that it deflects wind to the right in the northern hemisphere. One of the sources I was going through was Gold Seal's flight school. And Gold Seal's actually, it doesn't turn the wind. It looks like it turns because it's based on our perspective from a moving position. Okay?
So the Earth turns underneath it.
The Earth turns underneath. It's not really...
Because the air's a fluid, it's not moving with the Earth as it turns.
Sort of like it looks like the sun revolves around the Earth, when in reality the Earth is spinning and revolving around the sun.
Earth is flat and circular.
And surrounded by an ice wall.
And all the governments in the world for the last 200 years have been...
Alright, so the Coriolis effect is minimal at the equator. It is more visible the closer you get to the poles. And that has to do with angular speed. At the poles, you're moving faster angularly than you are down at the equator. Angularly. All right.
The inside of the prop versus the outside of the prop.
So, at the tip of the prop, the tip is moving faster than the inside. So, Alright, surface friction. It's interference from the ground, slows wind down, shifts the wind direction. Wind is parallel to the isobars at altitude. And what I found for at altitude is kind of anything above 2,000 feet.
Yeah, AGL.
Yep.
2,000 to 3,000.
2,000 to 3,000 feet AGL, your winds will be parallel to the isobars. And if the isobars are close together, they'll be parallel and fast. If they're far apart, parallel and slow. And then closer to the ground, they move to be cross the isobars. All right. And they will fly. They'll flow into a low. What's that?
Why does it change closer to the ground?
Because the
Skin
earth,
friction.
skin friction, surface friction.
So, do the isobars show like the pressure at the ground, at ground level, or
Whatever
like,
altitude.
or the charts for like specific altitudes?
So assuming a standard pressure lapse rate, they probably show generally from the ground.
What's that?
Like for the numbers they're given.
Those numbers should all be in reference to
Sea level.
sea level. So
Yeah, okay, yeah, that would make sense because our altimeter settings and everything's referenced.
everything is referenced to sea level. But and it's just it's relative air pressures, you know. All right, but the good news is you don't have to spend a lot of time and like mental calculation figuring out by the isobars what the wind is actually doing at different levels, because there's entire charts called the winds aloft charts that tell you what the winds are doing. And now you have the GFA. Does anyone know what the GFA is?
Something forecast.
Global.
Graphical
Forecast.
graphical forecast for aviation.
Aviators, something like that.
Aviators. That is like all of these tools put onto maps so they're easier to understand, and you can layer them how you want to. We'll talk about those next week. All right, so we talked winds. Dew point. What is the dew point?
The point at which the air cannot hold any more moisture to become fully saturated without the moisture striking contact.
And what is that point measured in?
Temperature.
Degrees Celsius.
It is a temperature. It is the temperature that if the air is cooled to that point, it becomes saturated. Oh, look, the temperature to which air must be cooled to become saturated.
Did you read these beforehand or something?
I wrote them. Didn't just read them, man. I wrote them. Warm air can hold more moisture. When the temperature and the dew point are the same, relative humidity is 100%. Relative humidity is a measurement of the difference between the current dew point and the current temperature. All right?
That's not saying it's particularly humid. You can have a 100% relative humidity and still be fairly dry.
I don't know that that's true.
If the air is cold enough.
If
the air is cold enough, you can.
Well, cold air. So we go back to warm air can hold more moisture than cold air, but
or I guess the what the humidity feels like. It can feel like low humidity, even though your air is.
Well, heat and humidity together just feels worse.
Feels like
air zones.
Which is funny because everyone in the pictures says the air is
Try Tennessee.
Have a good basis.
I mean,
Try Tennessee.
Okay.
Yeah.
How do we end up with frost?
When the air reaches a dew point below freezing, or when the air becomes fully saturated at a temperature below freezing.
When moisture freezes?
When the dew point is below freezing, and then the water vapor forms on surfaces, and it sublimates directly to ice. I'm sorry, sublimation is when it goes directly to steam. It condenses directly to ice.
Deposition.
Frost. Deposit. There you go.
Deposit.
Deposition.
Okay, I got a question on this.
How can you reduce lift by 30% but it increases drag by 40%? Wouldn't they be equal?
Nope. So the lift,
because your lift isn't the same as your
Here comes the
portion of
Scan
drag.
drag. Oh, nice.
The lift to drag.
So
ratio is
induced
all the
drag is a byproduct of lift. Parasite drag is just from everything that doesn't create lift. So it's from the antennas, it's from the structure of the aircraft, like the struts and stuff.
Gotcha.
So
So that would be an
since
increase
they
to
said-
skin friction drag because it's rough on the skin. So it's
You
not
just
creating
did all
any
this stuff for our oral
any
check.
byproducts of lift. All it's doing is
Wow.
creating drag.
Gotcha. So
So it's parasite
I
drag.
don't know why I said this.
And also,
So
there's-
it's not necessarily
Did
40%.
you make a plate out?
Alright.
lift and drag, they're also not a zero-sum game, right? If I have a certain angle of attack, the first bit of angle I increase it is going to increase my lift a lot and not increase my drag very much at all. When I'm getting close to my critical angle of attack, increasing my angle hardly gives me any more lift, but it gives me a lot more drag. So don't think of like lift and drag are not A,
Well,
B.
they have a
It's
scale.
like
Yeah.
on those flaps, the first 10 degrees.
It's that
in the
diagram. Do you
wild
remember
west.
seeing the diagram that goes up and down? It has like that little point in the middle that's your best glide speed. Like the graph.
I don't think I've seen
It's the like induced drag.
I will guarantee you saw it at some point.
Green and red.
It's the power curve drawing. Yeah.
Okay.
Okay. So, but reduce lift by 30% and increase drag by 40% is a definite FAA answer to more than one of their questions, actually. So, all right, frost disrupts the smooth airflow. It only has to be like sandpaper. Like you're not talking about, when you go out and your window has frost on it and you scrape it off with an ice scraper, that is way more frost than we're talking about. We're talking about just enough frost that you can feel it if you run your hand over it. All right? So, and the only real ways to deal with it, heat it, hang it, or move it into the sun. Sometimes, if you really need to go flying, what people will do is take
A wet wash.
a wet washcloth, or they'll get propane heaters, and they'll use them like blow dryers. Airlines, what do airlines do to de-ice the whole plane?
The icing fluid.
De-icing fluid, they literally hose the plane down with it.
I got a really nice picture.
Okay, do not use tools to scrape frost off. You will damage the surface. It damages the paint, and you can bend, especially like fabric airplanes, you can tear them. All right, so you just
They're all just sitting there on standby.
Denver also has a facility that is just a gigantic drive-through easy bake oven.
What?
Yeah, they literally tow the planes through it right before they take off, and they melt all the ice and snow off of the outside.
That's so cool.
And then on the other side, they glycol them down real quick, and then they have to take off within like 20 minutes, or else they have to go back through the process again.
Isn't
I mean,
Denver
that's
the
not
one
cheap.
that they get so much snow they have to load it through basically jet engines mounted on a truck because it piles up too much otherwise?
Probably.
Yeah.
I don't know. I do not know all of the answers about Denver's snow. What?
Denver Airport is totally insane.
Yeah.
I've flown out of there and it is nuts. Commercial.
It's great.
So, does airport provide that service? Because
At some airport, you won't get it for a GA plane.
but you
Oh.
have to pay for it. Like
Oh, yeah.
the aviation companies have to pay.
The
airlines have their own
the airlines
teams.
pay the airport. The airport has contractors that actually do the work. And yeah,
So, and
These are all like
just as a weird aside, there's actually, all that stuff is kind of toxic. It's like mildly toxic. And they pay a ridiculous amount of money for people to go clean it up. So I went to school with guys who their winter job was that they they didn't de-ice the planes. They cleaned up all the de-icing material. And they were making like 60 an hour.
I'm doing that.
Okay, there we go.
Because it's toxic.
That's
All
my
right.
job, dude.
Okay, we're gonna talk about fog. Alright. This is not rocket science, guys. Fog is just a cloud that's touching the ground. Is that fair?
Yeah.
It's a surface cloud. The problem is that very often those surface clouds don't move, and they 100% guarantee that you're flying into a place isn't happening. You cannot land in fog. Alright? Can you take off in fog?
Yep.
Should you take off in fog?
I mean,
It depends. More often than not, I would say it's a bad idea. Alright? There are some very, very rare occasions where, like if you know you have an airport, you could take off at Coeur d'Alene in fog if you knew that the ceiling at Feltz Field was low enough to make the approach in.
Here's an example I've seen here on more than one occasion. Driving in, and most of the area around here will be blue skies and clear, but there's a layer that sits like right on top of the airport. It comes up through the valley.
Mhm.
You can drive a mile down the road and you can see the entire rest of the valley, but the airport itself has just got a layer of fog over it.
Yeah, let's just do the location.
That's one I would
We should
say you should be able to take off then.
Well, the challenge is what happens if you lose an engine on departure.
Where you going?
Yeah. So, yeah. Am I saying I wouldn't ever do it? I don't know. I fly a twin engine plane, and I'm pretty sure I could make it to Sandpoint if I lost an engine, as long as I didn't let it roll the plane when it took off.
I'm just guessing.
So, that would be the
critical
big.
engine?
What's that?
Do you have a critical engine?
Critical engine.
If one engine,
Yeah, it tells him he's a lousy pilot every flight.
It's great.
It's really rude.
okay, we're going to be way off topic here, but twin engine airplanes, if both propellers spin the same direction, you have more thrust on the descending blade than you have on the ascending blade. And so if the left engine fails, the right engine will produce more thrust and turn you harder to the left than if the right engine fails. The left engine, the thrust is closer to the center line and it has less of an impact. The other reason that you can have a critical engine is if one of your engines has like the only vacuum system or the only alternator or something. Very few planes are built that way.
It's usually this guy.
But, well now, so they do make airplanes that have what are called counter-rotating propellers, and then they both spin so the descending blade is to the inside, which reduces the asymmetric thrust. But I wouldn't even say that most airplanes have counter-rotating propellers, because that means you have counter-rotating engines.
So a critical engine specifically refers to the engine that you want to be really careful about having it be the only one left working, or
It's
the
the one that
critical
if-
engine is the one that you
the-
want to be working.
Yeah, the critical engine is the one you want to have working.
Okay.
And if the critical engine fails, you're going to have the most detrimental effect to the aerodynamic performance of the aircraft.
That sounds quite.
And since we are not here to talk about multi-engines, we're going to move back to fog. All right. So, forms by cooling air to the dew point or adding moisture. How does fog form?
Yes.
Which type of fog?
Yeah, which
What type of fog?
Cold air moving over a warm water.
Radiation, convection, upflow.
It says right there.
Yeah. Cooling air to the dew point or adding moisture to air.
So there are two different ways that you end up with fog. Either making the air colder or adding moisture. All right? It's often prevalent in industrial areas because I told you before, water wants to stick to something. So there's dirt particles, there's pollution particles. Those give the water something to stick to, and that causes more fog. All right? Clouds, fog, or dew will always form when water vapor condenses. Clouds, fog, or dew will always form when water vapor condenses.
So, back to the adding more moisture to the air. That's basically the same thing as the air temperature cooling to the dew point, because in both cases you've just maxed out the amount of moisture that the air is able to hold. In one case, that air is cooling down so it can hold less. In another case, you're just putting more moisture in, meaning it can't hold as much as you put in.
Yes. When they reach the saturation point, you will have clouds, fog, or dew. All right, fog usually seeps present after rain. You have upslope, steam, precipitation-induced advection, and radiation fog. I don't know why I have that top sentence on there. That's a typo. But that was supposed to be on the previous slide. So that's a form after rain that adds moisture to the air. All right. I don't know how I put it on the wrong slide. Okay. 5 types of fog: upslope, steam, precipitation-induced, advection, and radiation. All right. 2 of these are caused by air movement. You have to have moving air. Do you know which 2 those are?
Advection and upslope.
Advection and upslope. There you go. That's something you want ingrained in your brain, because that will help you on the test. All right? So upslope. Moist, stable air is pushed up sloping terrain by wind. So if you have stable air going up a hill, you get fog. Moist, stable air going up a hill. If you have moist, unstable air going up a hill, what do you get? Vertical development and thunderstorm. Potential. All right. Steam fog. It's cold air moving over a warmer body of water. Think about a pot sitting on the stove, and you're heating it up, and the air in your house is colder. As it goes over the top, you get steam coming off of it. And that will help you think of steam fog.
So this one's also moving air, right?
Strictly speaking.
This one can happen on still air. Like, if you're ever driven by a lake, and you just see like there's fog over the lake, it's actually more like...
It's just the air has to be cold, and the water has to be warm.
Actually, if there's a lot of wind, it doesn't happen, right? Because it goes too fast to cause it. So, yeah.
So rising moist air is cooled to the dew point. Low-level turbulence and icing can sometimes occur. All right. Moisture is added to the rain in the form of precipitation. This one's not rocket science.
So this one actually happens a lot around the warm front. We have that stratosphere layer coming through because it's very stable, rains down, adds a bunch of moisture, and you get that low-hanging fog.
So warm fronts are a good place to expect fog to cause you problems, and for that problem to hang around for a little while. Advection. Advection is specifically air moving either from over water to over land or over land to over water, and you end up with warm, moist air moves over cool water, chilled lands cool, warm air to a dew point. And I note here, upslope and advection require wind to move the advance. You can have wind in steam fog, it's not required. Advection and upslope fog require wind.
Does anyone know how much wind advection fog can handle before it's technically just low clouds?
30 knots.
It's not 30 knots. This one is on the test that I've seen. It's 15.
Mm-hmm.
It's up to 15 knots of wind.
Yeah, I had no idea.
You just remember that?
Yeah, I know that.
We're all here to learn.
Yeah. I got you.
All right.
Well taken.
Yeah, I got that question yesterday on my study.
Did you? All right, radiation fog. Heat radiates from the ground. The ground cools from the loss of heat. As the dew point is reached, fog forms. This is sometimes called ground fog. Warm, moist air over low, flat areas on calm, clear nights. That is FAA speak. That is on the test. All right. Warm, moist air over low, flat areas on calm, clear nights. So, radiation fog.
Not down here. We're not low.
But down the hill, by the river?
Yeah, it can happen. Flat.
Yeah, in the valley.
So that one is very prevalent in the little valley where I live. You can walk out there, right about when it's getting dark, and the entire valley is just full of all the fog from.
Yeah, during the winter where I live, when I wake up in the morning, I almost guarantee you we're gonna have fog.
Yeah.
Every morning. Yeah.
It's beautiful.
So that temperature inversions, which are apparently Tristan's favorite topic, because we talked about inversions a lot today. Bottom line is, if the air stops getting colder as you go up, and it starts to get warmer, then you have a temperature inversion. All right. In my brain, and it just has to do with where I grew up, Lewiston, Idaho is like the home of temperature inversions. As you go from the valley down to the bottom of Lewiston and you go up the hill, you pop out on top onto the Palouse up by Pullman and the Moscow area. That valley will have a thick, dense layer of clouds that just sits in the valley. It gets capped in there. And it has to do with the fact that the valley gets really, really warm, and then that air rises up, and cold air sinks in through the river, and it gets trapped, and then it just sits there. And they have a lot of pollution from the paper mill, and that paper mill just creates a layer of fog and a nasty smell.
There's actually one going.
They actually call it the smell of money. But
down Northville, I've noticed. I've been riding my bike. There's a small inversion right about where the hill opens up.
So temperature gets warmer with an increase in altitude. That is a requirement for an inversion. All right. It's always associated with a stable layer of air. The air's not moving. Generally found from radiation on clear, cool nights with light wind. Traps pollution. Leads to low visibility, fog, haze. It's part of the reason the Lewiston Airport's up on top of the hill. May also cause wind shear because that warm air creates a layer. Now the odds are you're going to be moving out of an area that has wind into an area that doesn't have a lot of wind because it has to be stable.
You'll feel the bumps as you go through.
All right. So air stability. Stable air. Rapid temperature decrease with height encourages warm air to rise. So that, we talk about the standard lapse rate. So in stable air, it's probably getting colder faster than the standard lapse rate. In unstable air, it's getting colder slower than the normal lapse rate. All right, stable air makes stratus clouds, steady precipitation, smooth air, poor visibility. And if you think S's, stratiform, steady, smooth, stable air. And all those things give you poor visibility. Unstable air, you got U's in cumuliform and turbulent. It's messy. All right? But your visibility gets cleaned up because all of those particles get blown apart. All right, stability determines cloud types. Stable, and I don't know how I got those ass backwards.
Yeah.
That is absolutely backwards.
I think the last question was too, when it said vertical or, I don't know. But it says rapid temperature decrease, so it's getting colder faster.
Yeah, because it's colder faster, the hot air rises faster.
So would that be fast stable air? Or is that?
Jesus. All right. I may have to do an errata on this slide next week.
Yeah.
Because I know this one's wrong.
Yeah.
All right. Adiabatic lapse rate. In unsaturated air, the dry adiabatic lapse rate is about 3 degrees Celsius per 1,000 feet. In the saturated air, the wet adiabatic lapse rate is about 1 to 2 degrees per 1,000 feet. And I wrote myself a tiny note here. Adiabatic refers to a process in which no heat is actually transferred. It is purely due to the expansion or contraction of the air. And the standard lapse rate is 2 degrees Celsius per 1,000 feet. So you might want to know all three of these lapse rates. How am I doing here?
About 30 minutes. All
right, well, that's good. I got about 13 slides. Turbulence. Three types of turbulence: thermal turbulence, mechanical turbulence, and clear air turbulence. Okay, the fourth type. So, which is the most common, ironically, but it's not on the list. All right. So, thermal turbulence is caused by air masses moving up, small air masses just rising up.
That's heat moving up, though. It's not just, it's got to be warm air moving upward, right?
Yeah, well, that's what moves up.
Right.
Cold air doesn't rise. So, air that's warmer. And, like, if you've ever flown over, like, a big parking lot, kind of low, you'll get that heat rise during the summer.
The highway right there?
The highway? Yeah, you get, and then you get the weird sink on the other side.
Yeah.
Can you start going over the grass?
Okay.
The runway, and you go.
So mechanical turbulence is just what it sounds like. It's the air going over something. And you get small-scale mechanical turbulence, like at an airport that has a row of trees or buildings along part of the runway. The wind will come up over it, and then it crashes down on the other side. You get larger-scale mechanical turbulence when you start talking about mountain waves and that kind of stuff, all right? So mechanical turbulence is air movement over something or around something. In the cities, you'll get it coming around buildings. The air will come at different speeds and just smack into you. Clear air turbulence is just turbulence that happens out where you have no idea it's coming. They'll experience it in the flight levels.
It's like taxes.
What's that?
It's like taxes.
Yeah, except we know it's coming.
Well,
I
guess
two
so.
things are guaranteed in life: taxes and death.
That's true. You don't know when death's coming.
Death, taxes, and a headwind both directions.
Yeah,
there you
that's
go.
true.
So how do we report turbulence? What's the rating scale? What's that?
Pyreps.
Okay, we do pyreps. So how do you? What's the scale?
Knots.
Oh, light.
Oh yeah.
Oh, severe.
Light, moderate.
Light, moderate, severe, and extreme. All right. So light, momentarily. It's just a little bump. We've all experienced light turbulence. Virtual and I may have experienced it today. Little light turbulence. All right. So moderate turbulence, greater altitude, and can actually change the airspeed. And that's supposed to be like the difference. Light turbulence does not change your airspeed. Moderate turbulence can change your airspeed. Severe turbulence is usually the result of thunderstorm winds and can be reached as far away as 20 miles from the storm and can cause momentary loss of control of the aircraft. So that's severe.
Why stay 20 miles from.
Yes, because you don't want to lose control of your aircraft, even only momentarily. All right? And then extreme turbulence, the big one with extreme is it causes structural damage. All right?
Not the fact that little to no control.
I could probably cause more structural.
I'm more worried about the structural damage.
If you don't have an airplane to fly, you don't have an airplane to control.
Exactly. All right? So what is wind shear? I mentioned it a minute ago.
Rapid change in wind direction and velocity.
Look at that. When's it most dangerous?
Every thunderstorm.
Every time.
Every time.
60% of the time. Every time. What's that?
On landing.
Close to the ground.
That's what
Microbursts.
Oh,
Most dangerous is microbursts.
that's true, I guess.
No, well,
It's most dangerous near the ground.
Most
Come back.
dangerous to the ground.
the FAA says that wind shear is most dangerous when you're landing or taking off because you're close to the ground. You don't have time to correct for the problem.
Well,
Right.
I guess if you're straight level near the ground.
So,
Yes or not.
low-level inversions, thunderstorms, weather fronts, near mountains, and the jet stream, you will always experience wind shear. Now, low-level inversions, it may not be very, very dramatic, but thunderstorms and near mountains can be absolutely unbelievable. All right. Oh, wrong way. So short-term wind changes. There are two different definitions of short-term wind changes. There's gusts and squalls. This is definitely an FAA question. And the big difference is gusts last seconds, squalls last minutes. And in squalls, typically our wind speed changes 16 to 22 plus knots. the wind changes significantly for several minutes, as opposed to wind gusts, where the wind, and you'll notice wind gusts are typically like 10 to 15 miles an hour max. All right.
Above wind speed. 10 to 15 max above steady wind speed.
Yeah, whatever the steady wind speed is, plus like 10 or 15 knots. But squalls can get up to like 22 knots, greater than the base wind speed.
Where do they occur the most?
I don't have an answer.
Yeah, like a ground thunderstorm or something like that.
I don't have an answer. GTS. Okay.
What's GTS stand for?
Google that shit.
Google it and find out.
Okay, microbursts.
Deadly.
Absolutely deadly. That's on the slide in capital letters and an exclamation point. All right. So they are so deadly. There's an entire freaking devoted cult to trying to figure out how to predict them, because one of the problems is they're almost unpredictable. Almost as right now, we don't have any way to accurately predict microbursts. Relatively small, typically last less than 15 minutes, max downdrafts of 6,000 feet per minute. Okay, what is the maximum rate listed on most rate of climb indicators in GA?
2,000.
2,000 feet per minute.
Ours has it. 600 range is 2,000.
Yeah.
Well, I don't know, because 6, 9, or 8, I can't see what the max is because it's a digital.
Robotango has 2,000.
I'm thinking probably.
Yeah, 2,000 to 2,000. Okay, what are the odds of you getting a 2,000 foot per minute climb out of?
With me in the plane, 100%.
Oh, you and I are going for a flight. And if I win after that 4-hour flight, you have to pay me double.
Oh, yeah. Wait a minute.
So, alright, relatively.
So you have to be able to be at an altitude high enough that you can travel at 4,000 feet per minute down for 15 minutes to survive.
No!
That's not possible.
To travel downwards at 6,000 feet per minute for 15 minutes, you'd have to be at 90,000 feet.
No, that's
It wouldn't last for 15 minutes.
The maximum, if you were maximum.
So what happens is the air comes down, hits the ground, spreads out. All right, so it's coming down at 6,000 feet per minute. And I should have looked this up. I forgot. Do you remember what the headwind, tailwind shear is typical?
45 knots, I think.
Something gonna be saying like 7. Let me look it up for you.
Okay. So bottom line is,
80, isn't it?
when you first encounter the microburst, you are very likely going to encounter a headwind. Why? Because the wind blows out from the microburst in all directions. So you are in a headwind. That headwind is fast. I don't remember how fast. She's looking it up for me. When you go through the headwind, then you hit severe downdrafts, up to 6,000 foot per minute downdrafts that your plane cannot possibly outclimb.
168 miles per hour.
I was a little
45.
168, not the shear, that's one direction.
Yet, despite their small size, microbursts can produce destructive winds of up to 168 miles per hour.
That's a very precise number.
I know.
But so, if you think about that though, you're flying into a 168 knot headwind, which you would never make it into the center in a 172, because you just get blown backwards.
Well, actually, that'd be above our max structural cruise at that point. That's just like
You're in the air mass.
we're going into it.
You're in the air mass, man.
Okay, we're in the air mass.
So you're going to move with the air mass. So you're doing 100 knots into the air mass, but it's blowing you out at 168. So you have a ground speed of negative 68 miles per hour knots.
So yeah, I want to go do that sometime.
No, you don't.
Find a microburst right now.
All right,
Bill, you're giving him bad
Next
ideas.
slide.
All right. You will see this diagram on the test.
Very
We
unrealistic.
saw it on Prepware the other day.
That's not going to happen.
There you go. So, did you see it on Prepware?
Yeah.
So, all right. So you get this increasing head. So even if it's not the top of the line microburst, say you get a 50 knot headwind. When you cross through in the point that's being blown down at 3,000 or 4,000 feet per minute, you're also in a wind shear from a 50 knot headwind to a 50 knot tailwind, which means the wind is now blowing the wrong way over your wings, 50% the speed you can fly, and you are in a severe degradation of performance. You're being blown to the ground and away, and you don't have air moving over, so you've lost a crap ton of lift. Which, yeah, you pancake.
It's God's vengeance on bad pilots.
So how do you, I mean, I know you probably won't, but what do you do to try to get out of that? Do you like add power and pitch down?
Mostly it's just the only indications that you might be encountering microbursts is that they can be associated with thunderstorms in the vicinity. All right?
And you should be able to see this massive column of descending air.
So, like the air will move so fast that you can see the turbulence.
And then on the ground, you can probably see everything move out.
Big dust cloud blowing out.
What they've done for air crews, because this happened to a commercial flight a couple of decades ago when they finally figured out what a microburst was. And the problem is when you get that increasing performance as you're coming in, turbine pilots will pull back to maintain their descent angle. And of course, turbines take a long time to spool up. So what they wanted the pilots to do is recognize an unanticipated extreme increase in performance. Don't keep the descent going. Do the go around right away. Keep the power in so that when they get to the other side, they're already climbing and they already have full power. They're not. They got suckered in. These guys, they pancake.
Yeah, it's a fascinating documentary if you want to watch it. It's
Is it on
really
Netflix?
sad. No, I think it's just on YouTube.
So,
So, documentary on it.
Is Mentor Pilot doing that?
And then the other thing is some airports have these systems called LLWS, low level wind shear, and so they may be able to report to you that there's low level wind shear reported in the area. But it's not going to be little airports; it's going to be big ones, Salt Lake City, those kind of ones.
but for you, like if there's a microburst on final out here, and if you're flying in on final, and you look out, and you're like, wow, that air looks really weird, and why is there all that dust? Go around, turn, avoid it, all right? Leave. It will be gone in 15 minutes. There's also, they had a whole series of microbursts that actually hit Sun Fun several years ago, destroyed dozens of airplanes. Because
hard enough level.
Oh, and Phoenix.
Well,
the
that-
airport in Phoenix got hit by one. And that ripped hangar doors off and stuff like that.
but now Phoenix got hit by one. The thing in Florida, if I understand, it was a cluster of microbursts, and it just
Florida.
was that
Just because it's Florida.
Florida man.
Florida thing,
All right.
Who knows?
Aren't they more likely
Icing.
in flatter, like they're less likely in mountainous terrain?
I have no idea.
So Kansas is cooked.
So Florida ends up with really, really brutal weather because of just where it sits.
I just think God also hates Florida.
Yeah. It's just everything bad's in Florida.
All right.
I've been good there.
God.
So icing causes aerodynamic degradation, a loss of lift, and it's an increase in total weight on the aircraft. All right. The other thing is unless you have de-icing equipment, you have no way to just get rid of it. All right. So there's three types of icing. What are they?
Rhyme, clear, mixed.
There we go.
Which one's the worst?
Mixed.
Clear.
It is clear. Yeah. You'd think mixed is harder, but it's clear.
So clear ice is glossy, transparent, forms slowly from supercooled droplets. Rime ice is rough, milky, and opaque, and it forms rapidly from smaller supercooled droplets. And mixed ice is just both of them together. All right? So what is you said clear ice is worse?
Yeah, because it changes the aerodynamic flow, and it's really, really heavy as compared to the Rime ice, where it does change it, but it doesn't change the shape of the wing as clear ice does.
No. I think I would argue that they are both equally bad.
Yes.
The FAA says that.
Does the FAA say clear ice is worse?
They say because they go over the airfoil and freeze.
And it changes the flow of the air over the wing.
So
it changes your wing camber.
Yeah, the problem is with rough ice, as with rime ice, is it can accumulate so fast. So go with the FAA answer about clear ice. What I'm going to tell you is If you don't have anti-icing, de-icing capability, ice is deadly, and so you don't mess around with it. When we flew back the other day after we encountered icing en route, what was one of the decisions we made?
We decided to fly back at 10,000 feet.
Why did we go 10,000 feet?
Because we were flying right under the cloud layer. We knew that once we got up to that cloud, we'd start building ice. And it didn't look like we would clear that cloud layer if we flew up into it, tried to get to our decided on altitude. So
when the deciding on altitude was 12,000 feet in 19 or 69 or 8, which may or may not make it to 12,000 feet. Given the temperature, we probably would have made it. It would have taken us a long time. We'd have spent a lot of time climbing through it. The other thing was when we were underneath, I could see all the way to Washington from where we were in Montana. And I'm like, I know that I can stay underneath, not hit obstacles, and I'm more concerned about icing.
Yep.
So, all right. So clear ice tends to form from 0 to negative 10 degrees Celsius. Large amounts of water, aircraft traveling quickly. Clear ice accumulates on faster planes more often than on slower planes. One of the problems with clear ice is it will form on and flow a little bit after the de-icing equipment, and then it gives something for the ice to grab onto and keep building layers back. Rime ice tends to form from negative 10 to negative 20 degrees. There's less water present, but it's more likely to accumulate on slow-moving planes. The trace icing we were getting was very clearly rime ice. Looks like sandpaper, like white, frosty, gritty. All right, reporting icing. What are the descriptors we use for icing?
Trace, like moderate severe.
Trace, come on.
Trace, you can just see it, which is what we reported. Trace icing. Light, it accumulates with over an hour. All right, so it's a big step from trace to light. Moderate requires frequent de-icing. Did I spell it wrong? Yep. Sever. Severe. De-icing equipment is overwhelmed. Exit immediately. All right? And if you don't have de-icing equipment, you should have already been exiting. Because how are you frequently de-icing? Is Callie climbing out on the wing with her credit card and scraping it off? I mean...
Yep. I get paid to do it.
Well, it's the only way you're going to get to wing walk now.
Right? I know.
All right. All right, icing encounters. Change to an altitude above freezing or below negative 5 degrees or negative 10 degrees Celsius. One of the things that throws me off in 6, 9, or 8 is the outside air temperature reads in Fahrenheit. I don't know why, and I don't know if that's something we can have changed. Because you're supposed to report it in Celsius.
For doing an oil transfer tomorrow, they can have to look at it and see.
Okay. I would. How do you feel about that?
Say again?
Seeing if they can change the outside air temperature from Fahrenheit to Celsius on the...
Oh, I would love that.
Well, they're right. Can they change
Well,
the
actually, I think I know.
I believe the reason it's in miles per hour has more to do with the POH.
Yes, because just the way that aircraft was certified originally.
So I think you can, and which is weird because I think it used to be in Celsius.
Like somebody else changed it?
Yeah. So I'm seeing that you can.
Okay. So not to go down a weird rabbit hole, but it's more useful and more logical to my brain because the freezing point is 0 degrees Celsius as opposed to 32 degrees Fahrenheit, which caused me all kinds of confusion trying to do mental conversions of Fahrenheit to Celsius.
It threw me the other day when we were flying.
All right. Warmer air is present above freezing rain or freezing drizzle. And if you are in freezing rain, you need to get out of it immediately. All right. The problem is freezing rain accumulates so quickly that it is unlikely that you will be able to climb up above it if you're in it. All right. So if there's freezing rain ahead of you, you want to ask for a higher altitude now rather than later. All right. And it's illegal to fly into known icing with an airplane that's not FEAKI equipped.
If it's freezing rain, you know it's warmer above.
Yep.
So you want to get above it, right?
Yeah. But the problem is, if you're in freezing rain, you may accumulate ice so quickly, you can't climb out. Because you're losing, 30% of your lift and 40% of, and increasing your drag by 40%. And oh, by the way, freezing rain accumulates weight faster than any other kind of icing. Mm-hmm. I did get that right, didn't I? Freezing rain accumulates weight faster than any other form.
That's why clear ice is so dangerous. It's the weight.
So, but you do want to be aware that sometimes the better air is higher. And if you get above stuff, that gives you more options. All right. Now, we chose to stay under something, but that was because we could see what we were getting into. And we also knew the forecast was for raising weather, improving weather. Now, where does ice form first on the airplane?
The edge of the wing, on the wheels.
Curve. On the tires.
Okay. I wouldn't say it forms first on the tires. I will tell you on a 172, that's the first place you can see it. It's the easiest place, especially if the plane's painted white. Because it's white on black. It's easier to see. And it does accumulate. No, but you're kind of onto something.
Spin around the front. Just look out. No, tires is by far the easiest place to spot it first.
But what's that?
Look at the pitot tube. If you don't have pitot heat on, or if you have any small antennas or small fairings, small narrow spaces will accumulate ice first. Okay, this has a corollary problem with it though. If thin, narrow surfaces gain ice first, where is the most likely first accumulation of ice of significance?
On your propeller.
No. It moves too fast. It tends to sling ice. What's that?
Engine? Narrow spots in it.
Could be on your trailing edge of the wing. Something like that.
Air control surfaces?
You said thin.
Thin. Okay. So your front wing is like that thick, right? Mm-hmm. How thick is your tail? Your elevator and your much thinner, right? Well, the problem with that is it tends to collect on your tailplane first. Number one, you can't see it. Well, you might be able to see it in 196. We have a window in that.
We do, yes.
Yeah. So yeah, you can turn around. You might be able to see it. But if you accumulate ice on your tailplane, what will happen?
Your center of gravity shifts.
Potentially, but there's a bigger problem. Aerodynamic.
Stall.
And what happens when a tailplane stalls?
You die. No, because it's going down.
It goes up. Your nose pitches down, and you can get to the point where you cannot flare the airplane. All right. One of the things you'll notice is vibrations. All right. So if you're flying in icing and you have an autopilot, you should periodically turn the icing off, or turn the autopilot off. You can also get icing on the undersides of your wing on climb out. That's something to be aware of. Rolling condition indicates you're getting ice aft of the protected area. Now, this is on a plane that has de-icing boots because it will accumulate at different rates in different places on different wings. What are you giggling at? All right, if you have icing, autopilot, periodically fly by hand. You need to feel if the controls are making sense. And if they stop making sense, you need to hand fly the airplane. Maintain awareness. If you encounter icing, disengage your autopilot. Land with minimum flaps. Increase speed. Disengage the autopilot while you're landing. Expect a problem with flaring. And if necessary, divert to a longer airport. Because you're going to have a long rollout You are not going to have a lot of float. Because you're going to come in and the plane is going to just chunk down hard.
Stall at a higher airspeed.
You're going to be faster when you stall. You probably want to come in with extra power so that you can ease it onto the runway. And you're going to want to flare properly, but the plane may not be able to. So it's going to be a little bit of flying more with the throttle and just expecting a long run, a long landing run, a long. If you can, you want to kind of have a flatter low approach. But all right, I actually got all the way through weather theory. Let's go!
Hey,
Holy crap! All right.
I think you need to start talking for 1 more minute.
I think that's a new record, Phil.
No, I've actually gotten done early a couple of times.
Really?
Yeah, we're here good like 7 minutes.
That's like
You come to class.
Maybe if you finish on time, I'd be more excited.
That's nice. All right.
I'm saying.
This can you fly up on Sunday?
I only said that because you ditched me on Wednesday, so I'm mad.
That's cool. You two have been spending too much time together.
I was gonna say, I scheduled that whole.
I gotta wonder what it's like.
Easy to call me.